Good morning, everybody, and welcome to the DSG Metro Showroom in Plainview, New York. Today, we have a special treat for everybody. Our good friend and partner, Anthony Grimani, is here from sunny California to see some snow, get some good pizza, and talk about some acoustics, talk about his new products, the Grimani System speakers, which we will be installing shortly in our theater. And without any further ado, I'm going to turn it over to Anthony. Enjoy. And stay tuned.
Thank you, Dave. Everybody. So before I get started, I actually want to give a really big shout out to Dave. Dave Silken is an amazing guy. I've worked with many rep firms before, and this guy is special. So any of you guys who are working with him as dealers or as a contact, just know that he's not normal. He is like way above and beyond the call of duty when it comes to the work he does. So thank you very much for putting this on. So just the mere fact that he's putting on this little presentation and event and live stream, you guys can't tell. The people in the room can tell. There's two 4K cameras, there's lights, there's a live stream going on. This is not normal. This is beautiful. This is the stuff you do when you're in broadcast, when you're doing a news show, not when you're talking about audio for home theater. Anyway, so, I'm so glad to hear that. I'm so glad to hear that. So I am here to do a few things today. We have 3 hours?
As long as you'd like.
As long as I'd like. Excellent. So we got a bunch of hours to go over a bunch of different things. What I'm going to do is I'm going to weave a presentation that's going to talk about what home theater technologies and standards should be. How do you put one together so that it actually looks and sounds good? And in there I'm going to weave in what products we're building to help, I like to say, to aid and abate that process. So you'll see me kind of go in and out and talk about, well, you know, we have the speaker with that tweeter, but that's so that we can get this result so that in the end it sounds like a standard professional grade theater. So that's a lot of what I'm going to get into. The acoustics of a theater and what it should be and what it is that we provide to be able to get there. As a little bit of background, why I'm here. I guess I've been messing around with home theaters for close to 40 years now, which sounds like, you look like you're too young. I'm getting old. And 40 years ago, that wasn't happening. Well, here's my story. I studied electrical engineering. My dad was an audio engineer. My mom was a professional opera singer. It's in my blood. This business I'm doing here, this is just what I was born and bred with. I was lucky enough right out of my when I got my bachelor's in electrical engineering to get a job at Dolby Labs in San Francisco. At the time I was hired to design microchips for cassette decks. Remember cassettes? You're probably a little young, I don't know. I hear they're coming back. I hear it's a new hip thing is cassettes. So I was hired to do that, but I could see this thing over there that was like happening that was home videos, really interesting, and I could see Dolby had a technology to play surround sound in movie theaters, and it was like, let's put this in the home. So you got to think back, go all the way back to 1984. You know, no DVDs, no streaming. You know, your movies either came on a VHS tape or a Laserdisc if you're really serious about it, and those were the sources then. And at the time, it was like, man, we got to do this Dolby Surround thing. We got to bring this into the home. This is a lot of fun. So that's kind of my start in the beginnings of home theater before that word was even coined. So I was at Dolby for 5 years, and then I went to work at Lucasfilm, at the George Lucas Film Company, to start Home THX, the residential version of the THX technology program that was already in movie theaters. So for about 10 years, I worked hard at laboring on getting licensees on board to adopt the technologies, put them into products, and been in front of a lot of home theaters from that 15 years. Then about 22 years ago, I left that to start a consulting company that designs home theaters. We also design screening rooms for professional applications and recording studios, but the majority of what we do is high-end, what I like to call home cinemas or private screening rooms. And then along the way in this journey of being really a designer, calibrator, engineer, bumped into some ideas on how to make a better speaker system for home cinema applications. And better meaning, well, it sounds more better. That's important. There's some really good gear out there. But better really meaning an access to getting good sound faster and quicker. So one of our propaganda pieces you'll hear me say is a faster route to audio excellence. There are things out there from speaker manufacturers that make it difficult to get to really good sound. And if you take enough time to tune it and place it and equalize it and do all the stuff, you can get to where it sounds good. But why should it take 4 hours to do something that you could just do in half an hour if the product is designed correctly from the start? So that was part of the genesis of this new concept of starting a speaker company called Grimani Systems, and using new technologies, using new approaches at speaker design and acoustic design. We launched this thing 5 years ago. Now there's a full line of speakers I'll talk about during the session today. And Dave's going to be putting one in the demo room, like he said. And we've now done, sort of losing track how many installs are there. If I think about serial numbers, we're at number 525 or something. So we built 500 or 600 speakers, which is just kind of the beginning, but that's like where it sort of starts to hockey stick, like we got this process. So without further ado, let me push the right buttons. Hope this works, hope that works. Go over here. And that did work. So I like to say that the speaker systems we've developed are about ultra-high definition sound. And what I mean by ultra-high definition is just like in video, where we've gone from standard definition to high definition to ultra-high def, also known as 4K. We want to bring that grade of resolution and quality, that level of really chiseled, really clean, very obvious sound staging and sound quality into the audio business. So, talking about that, so we're all in the AV business now, right? Some of us may be selling a bit of two-channel stereo, where you get one of those vinyl records and you drop the needle in the groove and it makes music. That's kind of fun, and people feel like that's really hi-fi. I won't get much into that. I will say that us old audio engineers always thought of vinyl as a highly compromised process. It's a miracle it can even produce sound when you think of dragging a little diamond down through a plastic groove. And that compromise is very audible in a studio when you listen to the master tape, the master mix, and then you listen to the vinyl record, you go, well, that's not even close. But it's a pretty fun, it's a fun process to be listening to that. I'm going to talk about close. What does close mean? So when an artist, either a music industry artist or a film industry artist produces a soundtrack, produces a sound, there's a thing that they're hearing, that they're experiencing. And what they want to make sure of is that when it gets released into the world, it sounds the same. And vinyl can actually distort the sound quite a bit. Some people like those distortions. VHS tape did distort the picture and sound quite a bit. Some people got used to it. We got out of that. But we in this business, the folks who are here to deliver a well-integrated home theater, need to be thinking about reproducing the intended original reference visual and audio performance. And I take that little digression into vinyl to go, well, while it's sort of fun, in many cases it's not exactly what the artist was intending to hear or hearing from the master mix. So I want you to keep that concept in mind, that what we got to do is not just produce loud sound and big picture. We want to produce picture that is exactly what was seen in the studio when the picture was being either edited and timed and all of that, and sound that sounds exactly like what the sound designer and the sound mixer heard on what's called a dubbing stage, the final mix space where a movie was made. And so that's like the mission. Now, we do audio and video. The video business has evolved tremendously over the last 50 years. We've gone from, on the left side, a little black and white TV in a wood box or plastic box, playing the Beatles on the Ed Sullivan Show back then, through these steps. We've gone through color TV, we've gone to projection TV, those big boxes with 3 tubes and a giant screen. We've gone through high definition TV, plasma sets, LCD sets, 4K, 8K. And interestingly enough, there is this chart all the way up there that shows the cost of living evolution over the last, where does this start? Starts in 1920, I believe, and goes up to 2020. There's a little hockey stick there. But if you look at the evolution of cost from this time, from 1966 to 2022, a 75-inch 4K TV costs less today compared to the cost of living increase than that little crappy black and white TV cost back then. So video has evolved tremendously, right? We've gone from these big CRT-based black and white sets to these things that are barely this thick and hang on the wall and produce a big, beautiful image for not that much money. It's tremendous. It's unbelievable. So it's cheaper today to get a video experience than it was 50 years ago. Meanwhile, in the speaker business, we've gone from 50 years ago, tweeter, mid-range, and woofer in a wood cabinet with a passive crossover, through 20 years later, 30 years later, a woofer, tweeter, and mid-range in a wood cabinet with a passive crossover, to today, the majority of speakers made are still a woofer and a tweeter, a woofer and mid-range in a wood box with a passive crossover. And so, in a way, the way speakers are built today is barely different to the way it was 50 years ago. Things have evolved a bit. The drivers are better. We understand better how to make them reliable, how to make them produce good sound. But overall, the technology has not evolved. And is that a problem? I don't know. Was it a problem? Was it a problem to watch this? I remember when I was a kid, we were perfectly happy to watch this. We enjoyed it. But when you know that that's available, why would you go back to this? Same thing in the speaker business. New technologies are available that make this modern, that make a speaker experience today be something completely different to what it was 50 years ago. And that's what I'm going to talk about. Like, what are the opportunities? What things can we do to make a sound system be more modern, work better, be more reliable? And that's everything we're about. So, our mission statement at Grimani Systems, first thing is a quicker route to audio excellence. And I know Michael Restrepo, everybody, is in the room. He's in the house. He mentioned yesterday, every time he hears somebody say, well, I'm going to do this for you quickly, and you're like, yeah, right. Well, Michael, believe me, from slogging it for the last really 30 years, from room to room to room, with equipment to go debug, calibrate, test, tune, I have seen all the different ways, the different approaches that amplifiers and speakers and wiring make life difficult for you. And while nothing in our business is really easy, otherwise they wouldn't need us, I have found a lot of, my partner Manny Lacaruba in this business and I have found a bunch of different ways to make this a better and easier process. It still works. It's not like coming in and just dropping the thing in there and wirelessly making it all happen. But there's a bunch of things we've done to get that audio excellence to come out a lot quicker. So, second mission statement is what we call sound power. Now, that term is actually a technical term in loudspeaker design, which is the net energy that goes into the room. Some speakers tend to hotspot in one direction. So if you're right in front of them, or in the case of an Atmos system with top speakers, if you're right under them, like a shower, you're getting good sound, you move off from the intended sweet spot, and the sound's not so good. That's not what a home theater is. A home theater is not a solitary environment. It's a place where you can have 3, 4, 5, 10, 20 of your best friends all hanging out. Everybody needs to have good sound. And the sound power of a speaker, its ability to produce a bubble of sound that's even in the room, is a thing that very few manufacturers have been paying attention to. It's not a new concept. It's been around for a while. There are some people out there that put some effort in that direction. We're all about that. That's like our main thing. We make speakers that whether you listen to them here or there or here, they sound the same. And that's really, really key in a home theater environment. Next mission statement is to use new school technologies. I would say that I'm getting back to this business of vinyl. I'm not harping on vinyl. And by the way, last weekend I stopped at a garage sale where the guy was selling about 2,000 different albums, and I bought a whole bunch. Okay, so I am culprit of using that technology. It It's nostalgic. It's fun. It's not the best, but it's nostalgic. When you guys are doing integration work, you're not going in to install nostalgia. You're going in to install something that works, sounds good. It is not going to get callbacks all the time. It is not finicky. And believe me, nostalgia and finickiness, I know. I drive a 1937 British car, okay? That's nostalgic and finicky. You know, every time you start it, you got to go on there and fix something. Let's retweak the carburetor because today things are a little different than they were yesterday. Okay, is that a business you want to be in? No, that's what I do on the weekends for fun. So what we've realized is that there's a whole bunch. You guys want to come in and sit down? You like to stand? Okay. So there's a whole bunch of new school technologies available to us in making speakers and sound systems. I'll talk about them, and those things make our speakers Internet of Things compatible, which means that from this office I could ping a speaker in Belgium and go, "How are you doing? What temperature are you running at? Is your tweeter working? Are you sleeping? Do you have power?" And you go, "Well, that's cool. Why would you want to do that?" Because we need to cater to our clients with the level of white glove service that they expect. If our client says, "My buddies are coming over tonight, I just want to make sure this thing works so that I'm not embarrassed because when I hit play to blow them away with this amazing movie, it just blank screen and no sound," that client can actually call you and go, "Can you make sure it works?" You don't have to get in your car. You don't have to do a truck roll to go over there. With our sound systems, you can actually do a few quick remote verification tests and go, "Yep, clean bill of health." Now, if something's not working, you can tell ahead of time. Is like, "Mr. Client, you know what? I'm going to send a tech over. We've detected a little issue." And the tech can show up with either a spare part or go figure out what's been unplugged or whatever before the client is embarrassed. And that's what our clients expect, right? We're already doing that with their networking. We're already doing that with their power control. We're doing that with everything else. It's now time to do it with the sound systems, and you can do it with the video if you have the right displays. The other mission we wanted to do, and this kind of goes hand in hand with a quicker route to audio excellence, is to find ways to streamline all the interfaces. In our dream, and it's happening pretty soon, everything is connected through Cat6 cable. The output of a surround decoder has a single Cat6 output. That goes to all of the amplifiers with Cat6. Everything is really, really streamlined. We're getting there this year through technologies called AES67 that are integrated into our systems. Also in the streamlining, we like to offer complete solutions, which is a combination of the full system and the design services you need to know how to put the system in the room, and a calibration service, and a bunch of acoustical materials that go in the room all in one package. So you don't have to sort of think about, well, what amp do I need? What diffuser do I need? How do I calibrate this? What do I do? What do I do? It's all there as one streamlined package. And finally, in our mission statement, because I think it's important, we like to make things that are bulletproof. Bulletproof being that you can crank them up as loud as you want. You're going to get to your ears hurting before you hurt the gear. And when we design the systems for the application, we carefully look at the size of the room, the acoustics of the room, and size the speakers and the amps so that they can play as loud as a typical movie would want to in the loudest peaks without any chance of failure. And so those of you who've already worked with us have seen that before we talk about money, I go, "What's the size of the room? What's the length, width, and height?" "I don't know. I got to go measure it." You measure it. "Okay, tell me this, and then I have this giant calculator that I put on there and figure out what is the sound pressure level given the seat positions and the type of room, and make sure that in the end the thing will play as loud as it needs to play without any problems. And you can actually do that to within a decibel or two. You can get really accurate predictions for what the sound pressure level is got to be, and very few manufacturers do that for you. We think that's important. All right, so we like to think that performance is important. Sometimes older guys in the audio business go, "Nobody cares about audio quality. You could just put out sound with the MP3. That's not true. People do actually hear good sound quality. I'm in Helms all the time. Like yesterday and the day before, I was calibrating systems around the New York area. in which there is a sound system that was put in. It wasn't yet completely commissioned and tuned, but the client had spent a little time listening, spend the day tuning everything out. And it takes a day because there's only about 20 speakers in the room by the time you do the fronts, the sides, the backs, the tops, the subwoofers. There's a lot of gear to tune, debug some of the connections, some of the networking, some of the configurations, get it all tuned, bring the client back in and go, okay, I'm going to give you a demo. I don't say anything. And they're like, whoa, that is way better. And we start with a good sound system and then tune it to where it sounds reference, good, high quality. They can tell. So the good news is the client base out there understands what good sound quality is. Knowing how to get there is a little challenging, but once you give it to them, they can tell, wow, the voices are so much clearer, the bass is so much better, I feel so much more immersed. They can tell. So performance does matter. But in the range of performance, what matters a lot is that the performance be what I call reference grade. What does that mean? Like what is reference? And like people go, well, this is a reference quality thing. Oh, what is that? Well, there is a reference in our business. And the reference for movies is the international standard for how mix rooms are built. So you probably didn't know this, but there is a document issued by the Society of Motion Picture and Television Engineers, CEMTI as it's called CEMTI 202M, that says, here's what the sound system of a mix room, a place where you're making a film soundtrack, here's what it should do. It's all of the specs for what the speakers, what the amps, what the acoustics should be, so that what you're hearing and experiencing is standardized, is referenced. And normally if a mix room is built in New York on those standards, or in Moscow, or in Hollywood, or in Sydney, and you take the same film to those locations, it'll sound the same. What we're trying to do is to bring that into our customers' homes. Produce home theaters, home cinemas, private screening rooms in which the sound quality is exactly the same as where the movie was mixed. And you can do that. You just follow the recipe. It's like you do this, you do that, you do this, you do that, and you get there. When I design and calibrate rooms, that's what I'm after. I'm after something that in the end sounds good. Now, I've been lucky enough to hear a number of movies on dubbing stages, the places where they're mixed, and so I was there participating in it and going, all right, well, this is what that sounded like, and that's sort of burned into my memory. And when I go to people's homes, that is what I listen to at the end of the calibration, go, did this sound like it did on the mix stage? And I stay there and I tune it until it sounds exactly the same. And by that point, it's glorious. So same thing for music. What is the reference standard for music? It's a little more fuzzy, but there's a certain sound quality you'll hear in most studios if you go around the world and just take the same track and listen in a recording studio here, here, or here. There's a certain aesthetic that the sound has, and we just need to reproduce that. So if you do produce reference quality sound, you will have breathtaking dynamics. The difference between the quiet sounds and the loud sounds will be very, very extended, about 100 dB. The difference between the silences and the peaks will be fully present. There's a bunch of things you need to do to get there, and that is what we do. The bass needs to be very impactful to have reference sound, and that's one of the hardest things to do in the room and the room sizes we're working with because of this thing called standing wave resonances, and we designed the system so that they get around that. Today everything is about immersive audio and immersive video. It is really important to produce systems where you're not really hearing speakers, when you don't feel like, oh, I'm listening to the soundtrack and I can hear a speaker here and I can hear a speaker there and a speaker there, but instead that you feel like you're in this bubble of sound. And there's a way you can design a speaker to where it hotspots. So you go, I can hear it right there. And there's a way you can design a speaker to where it just lights up the room with a really immersive and even character to where it's like, man, I'm in the movie. So yesterday at the end of the day, I was calibrating a theater not too far from here, and brought the clients in. The lady of the house said, you know, before you did this, I felt like I was watching a movie, like it was there. I don't quite know how to explain this, she said, but now I feel like I'm in the movie. It's like it's around me, and it's like I'm right inside it. It's like, that's it. That's what we're trying to do. You can talk about hertz and distortion and percentage of THD and all kinds of technical terms, but experientially, what we're trying to do is to make these bubbles, these rooms called home cinemas, where somebody's in there, they hit play and then get transported into the movie as quickly as possible. So it was really, the woman felt a little bit embarrassed to use this like plain English language. It's like, that's it. You said it right there. Perfect. It was thrilled. Now, this is a little trick we work on a lot. Every listener gets a good experience. So I've already brought up a few times this business of hot spotting and focus and sweet spot. We, in our sound system design, along with wanting to produce reference grade sound and make it easy to install and all these things I've mentioned, it is really important for us to feel like whether you sit here or you sit there or you sit there or you sit down here in a beanbag, you get the same experience. And that's not easy to do. It's really hard. And there are ways to design speakers so that they produce a much wider and much more even distribution into the room, what we call sound power, to where you can actually walk around 3 rows of a theater. Like, let's say you have a pretty big theater, 5 seats across, 3 rows, and you can sit in the front row on the right, and then you can go in the middle, and you can go in the back row on the left, and get a very close experience. And to us, that's key. So let's talk about the reference a little bit. This is the standard of sound for movies, a room like this. So this is a picture of what's called Mix D at Skywalker Ranch, where I used to work at, on Lucas Valley Road in the town of San Rafael in Northern California. This is a pretty room. It's got a big piece of hardware in the middle called a mixing console. This is actually, I realize, a little bit of an older picture now. But this is where an Oscar-winning sound designer and mixer are going to sit going, this is how we're going to make this movie. There are no electrical factors that say this is where you turn this knob. It's all experiential. You just move the knobs until you like what you hear. But you are hearing it in a reference environment, a space that's been designed and built on the standards. And best place to, like this is a picture of the movie Willow. That takes us back a few years ago. If you wanted to hear Willow exactly the way it was designed to be heard, you would want to go in here and play the movie in there. And that would be cool. Or you can go into a room that was designed so that its acoustical character and sonic performance is similar to that. So that's the concept of reference. So that's one reference. This is another reference also at Skywalker Sound. This is known as the Stag Theater. It's the main screening room, beautiful sounding room, built on the same standards. You can go back and forth between this room and that room in the building and hear exactly the same sound. And really our mission today is to reproduce that in rooms like this. So this is actually a room that won for best home cinema at CEDIA, not 2021, but 2020, if I remember right. It's equipped with our speakers. Glorious sounding room. You play a movie in there and it sounds exactly the way it's supposed to. Client's really happy. They love the room. They use it all the time. So this, I think this won, best theater for 2020. All right, any questions?
Anthony.
Yep.
You touched on movies and music.
Oh, hold on one second. Speak into the mic.
You touched on movies and music and about critical listening. How do we achieve high definition music audio on the same system as we have set up for video listening? Aren't they 2 different types of listening playback?
Yeah, that's a great question. I love that question. I'm going to say there are legends out there that say, well, there's a speaker for rock and roll and a speaker for classical. Do you remember that? I do. There are legends out there that say there's a speaker for home cinema and there's a speaker for music. It's a legend. There's an observation that some speakers sound good on music and not so good on home cinema. And some speakers sound good on cinema, but those are observations. And really what you're observing is a not good speaker. If a speaker has good resolution, good frequency response, good sound power, low distortion, and can play loud enough to sustain the peaks that happen in either loud music or loud home cinema, it will play across both genres. And I found this for years and years and years and years. There certainly are speakers that are, let's just say, kind of shouty, they're forward, and you don't notice that character so much on cinema because there's not a lot of conditions in a movie soundtrack that have sustained strings and things that are like, "Grr," and instead it's, you know, it's dialogue and sound effects and things like that, so you don't notice it too much, but you're happy to have the sound pressure level and dynamics capabilities of them. And then there's speakers that sound great on music, but when you crank it up a little bit, you pop tweeters. Both of those are bad speakers. And so over the years of doing these things, I have seen speakers that can very, very well handle one and the other, and certainly in the design of our speakers, they're made exactly that way. Now they're made that way because that's the right way to design a speaker, but also because there's this beautiful tension between my partner and I, Manny. So despite the fact that I started in this industry as a musician, my main development in my early career was all around film sound. So I know a lot about that. Manny, my chief engineer, was the chief engineer before he came to work in what he's doing now of what's called the Plant, which is a recording studio in the San Francisco area, in which, you know, if you look it up and you look at the hundreds of amazing albums that were recorded there, it's a very well-known studio. But he comes from the music side. So we have this interesting tension, which is I'm all about making sure the film sound is right. He's all about making sure the music sound is right. And we out of our marriage comes a baby that produces both really, really well. So we'll take a break in a few seconds, and I'll just play a pair of our smallest speakers called the Rixos S on music material, and you'll see, man, this sounds amazing. So some of you guys have been to our office in California and have heard a pair of our biggest flamethrower speakers just playing a little classical concerto. And so imagine you're in front of these big things that look like a giant PA speaker, right? And you play it quietly and it sounds like a little audiophile speaker. Because there is really nothing endemically in the design of one application versus the other. You just want to make a speaker that's linear, that has good sound power, that's got good frequency response, and it'll work well on everything.
I remember being there and you had a baby alpha.
1 second, we need oh, yep, there we go.
I'm probably not supposed to talk about this.
Don't talk about it.
Nah, why not? So you had these like baby alphas kind of hidden away. Any chance, because I've been dreaming about having them as my desktop speakers. So like any chance I could get a pair of those.
That's funny. So Michael's mentioning this. So the Alpha, I'm about to get there. The Alpha is our big speaker. It stands about this tall, and it's a flamethrower. It puts out about 135 dB. It's designed to be a front speaker in like a 40 or 50 foot home theater, big one. You guys heard it there in a room that's much smaller, but it's designed to play loud enough and good enough to be able to light up a 200-seat movie theater. And then just for fun, we made a little mini version of that, actually 3D printed with like a little 2.5-inch driver and a little tiny little tweeter. And, you know, just for fun, let's see how this scales. And it sounds, like you said, it sounds pretty amazing. So right now it's just more like a little fun exercise. And, you know, maybe one day for fun we'll make a Christmas gift out of those and send them to everybody. I don't know, we'll see. But yeah, that's not quite on our roadmap right now.
But I got to admit, is even where you have perfected sound, the craftsmanship of the speaker, because even if we talk about the Alpha, where I think esoteric speakers are kind of coming back, the Wisdoms, like those big things, and the design looked like a speaker hanging off a bracket, which I thought was kind of beautiful. Like the craftsmanship, I don't want to say over-engineered, but like engineered just right.
Yeah.
And it was beautiful. I got to give it the edges, and you see it. And even your waveguides and all that, like, they're perfect. Everything is done, like the edging, everything is, you know, all the little distances. And I love all that detail. And watching the lab, and even I think what really kind of blew my mind is being in there, and they were like, here, we have the two speakers. You'll hear the differences in them. And taking that over and above, I've bought a lot of speakers, a lot of expensive ones, and I fell in love that day. I got to admit, I commend what you guys are doing, and
thank you.
I'm really excited about using the product.
Thank you. Michael Restrepo, a fan, thank you. It's a little hard to understand all of the things we worry about. I was almost going to say obsess about. That's not quite the right word, but we care about all the things that we think matter in the end to that desired experience of being immersed in the movie, which is just about producing a reference environment. And when you come and look at how we go about these things in our lab, in our factory, in our offices, you kind of get it. Just talking about it here, it just sounds like propaganda. You're lucky enough to come over and see, cut, like they say in French, cut the crap and actually see what's there. So on the fit and finish, we don't over-obsess about it. There are speaker manufacturers that do amazing woodwork and just gorgeous, gorgeous finishes, high gloss out. And in the end, half of the price you're paying is for the finish of the speaker. That doesn't change the sound quality, it just looks pretty. It's a nice piece of furniture. We take it enough to where it's like, yeah, it looks good, it looks respectable, but anything beyond that, you'd be spending useless money on something that's going to be hidden behind a screen or hidden behind stretched fabric, so no point in going past that. We do make I'll get to it. We do make a pair of speakers that's designed to be seen called the Tau, and there we do obsess about really reference lacquer, just very, very a piano grade finish. Most of it is just nice looking, good enough to be respectable, knowing that in most cases it won't really be seen. So yeah, but thanks for noticing that.
Now, it's great to see the horns on them, where I'll say horns just to dumb it down to kind of where everybody looks at it. Now, something that we would all be used to, and a lot of speakers are kind of, they end up where they really start sounding really, and you have this effect now. We see ribbons come out, but ribbons have their own problems, but to see you, and then I love the term waveguide, like all that, to see this kind of technology. And then you took it even a step further, where even the direction of it. Can you kind of elaborate how did you get there?
So I'm going to spend a lot of time on the waveguide, like in a few slides I'm going to go into that. But all of our speakers have this funny looking mouth. Is that on camera? Can you see this, or do I move it over? Oh, our cameraman's going to come to work. So all the speakers we make have, you'll notice that they look a little different in that they don't have a tweeter that's on the faceplate. They don't have a visible horn that's on the faceplate. They have this funny looking mouth that kind of looks like a Maori warrior logo, like, and it's not made that way to look mean. What's actually going on here in this case, there's a tweeter inside here pointing down into it, and the shape of this mouth is designed to spread the sound out evenly. It's not designed to do what a lot of horns do, which is to focus the sound in this direction. It's actually doing the inverse. It's designed to scatter the sound out very evenly, so whether you sit here or there, you get the same sound. And I'm going to go over that. This is the invention of Manny Lakaruba, my partner. This is the amazing technology he brings to this, realizing in his life quest to get even sound power that this is one really good way to get there. Other manufacturers do some of this by putting multiple drivers pointing in different directions, or by making these totally different egg-shaped drivers that spray sound in all directions. This is our approach at getting smooth sound power. And I'm going to keep using that term, sound power, because ultimately in the evolution of speakers, drivers have gotten really, really good. Woofers, mid-ranges, and tweeters have gotten amazing. The cabinetry has gotten amazing. Everything's gotten amazing. The next step is an obsession over the sound distribution in the room. The ability to make sure that no matter where you're sitting, no matter where the sound is bouncing from, it's a really, really even frequency response. So I'm going to go quite a bit into that, Michael. So I'm going to talk about the products themselves and then discuss the technology of the products so that you understand, like, well, okay, so I see a product, it looks different, why'd you do this? Not just to look different, there is a good reason. So in our range of products, I'll start with what Michael mentioned as the Alpha, our big bad boy. If it was actually here live with me, it'd be a little smaller. It's actually from here to here. Pretty much to scale.
I'm really short. I'm only 4 feet tall.
But this is we call it our flamethrower. It's a 3-way active speaker, 12-inch woofer, a pair of 6.5-inch tweeters, and a really, really high quality annular compression driver that fires into a waveguide up at the top. The speaker is internally amplified. This bottom section down here has 1,750 watts of amplification, has a DSP crossover, so the signal that comes in is filtered for the woofer mid-ranges and tweeters, not by a passive crossover like traditional speakers, not by an analog crossover, which is pretty good, not an active analog, but it's actually a digital crossover. And by being digital, you can do things in terms of shaping the sound and the accuracy of it that you can't do with analog domain processing. Or you can, but it's really, really hard. You can plug a digital audio stream directly into the speaker. If you're lucky enough to have a surround processor, and there's a few on the market out there that spit out direct digital, either through audio over IP or what's called AES EBU, you can plug directly digital in, then the signal stays in the digital domain all the way till the end. Or you can plug in an analog connection through either an XLR cable or an RCA cable on the bottom, and then it gets converted with a 40-bit converter into digital domain. So it's really wide dynamic range digital, completely pure, completely clean. And then the processing is all done internally. There's two stages of processing. One is the one that filters out the signals that go to the different drivers. The other one is for room correction. So built into the speaker is the ability to tailor the speaker to the room's acoustics. And we do that by measuring the room, looking at the errors, and then introducing a set of filters into the correction circuit to neutralize out the room, both in the frequency and time domain, because we can measure that and we can correct in both of those domains. So this thing plays stupid loud. It has a retail of $31,000, including the amplifier. That's the retail price per speaker. And it's an amazing sounding speaker. It looks badass, and it plays really, really, really nicely. And I love bringing people to our office and put them in front of that pair of speakers and start with something really gentle and quiet. Just like super sweet. And like, wow, that's coming out of these giant towers? It's like, yeah. And then I switch to AC/DC just to make the point that, yeah, I can also play that at stupid loud levels, at AC/DC concert levels, which is a few decibels.
But even like club music. Because I know we were in there having fun. We were like little kids, like, let's break it. So, and no joke, at one point I had to even act, like, I am that idiot. I'm going to break it. So I'm like, can I
break it that time?
No. Let's not talk about that. But, you know, I had to play with it. And the thing took it, sounded amazing, and everything from club music to classical, it rocked out. It did what it was supposed to do. I was amazed.
Yeah.
I think the images you see make them look a lot wider than they really are, because they're right at that edge. They kind of cut off and are flat. They look like they can be like wall mounted.
Yeah.
But they are the finish. It's even from the front. It's so three-dimensional. It's beautiful.
Yeah. It is designed to be wall mounted. So the brackets that you saw in the back that look like towel bars are made so that you put a bracket on the wall. You pull the speaker out of its box and you hang it on the wall. And I'm going to get to this. You pull the speaker out of the box. How many guys or gals does it take to pull that speaker out of the box?
4.
4. Is that something to be proud of?
No.
If you're an integrator and you're going to get 4 guys to pull it out of the box, is that something to be proud of? No. Guess what? This thing weighs 60 pounds.
Oh, wow.
I weigh 125 pounds. On my own, I can pull that thing out of a box and hang it on the wall. Now, that was one of the things that we spec'd in the beginning. Part of that easier path to audio excellence, streamlining the process, was, hey, Manny, you got to make a speaker that plays really loud but that I can pick up on my own. He's like, that's crazy. I don't know, figure it out. And so it's made out of tungsten impregnated urethane. It's not wood. Wood's heavy. Urethane with tungsten inside it is very, very strong, and you can make the walls much thinner. It's very well damped internally. It's curved, it's well ribbed inside, so the thing doesn't weigh very much. But when you knock on the cabinet, it's like thunk, thunk, thunk. There's like no sound at all, and that's the genius of good mechanical engineering and good thinking in terms of material science. So this thing weighs 60 pounds. If you're an integrator, you can send one person in the truck to like haul it up into the theater, pull it out of the box, hang it on the wall. So I know that's a little detail. It's like, well, who cares? You know that it weighs 400 pounds or 200 pounds. Well, part of your business as an integrator is you got to have resources. I've seen 300-pound speakers getting hauled upstairs and somebody trips. Then you know what happens. Not only are you fixing a speaker, but you're also fixing the giant dent in the Venetian plaster that the speaker left when it went down the stairs. That's a bit expensive. Yes, and that
then
too.
that person isn't making you money. That's
So
the saddest part.
that's the Alpha. Big bad boy, you would use this as a front speaker in a big home theater, or if you have a client that's you know, Restrepo like, he likes to, you know, groove it on down and play really loud. Next up, we've got an entire series of speakers that we call the Rixos line, and Rixos comes from the Greek word. It's the Greek word for shallow. We started off making speakers that were, you know, pretty good sized. They were not eminently integratable into a wall, into a small cabinet. So we did all this research and came up with a newer waveguide that's actually flat form factor, and out of that we can make an entire range of really shallow speakers. In the shallow range, the biggest guy is called the XL, which stands for extra large. And it is actually all the same drivers, all the same technology that's in the Alpha. But instead of being in a tungsten impregnated, relatively deep cabinet, it is in an MDF box. It's 8 inches deep. You can put it in a wall, you can put it in a cabinet, you can put it in front of the wall, whatever you need to do. It's $15,000 or $14,900 with the amplification, so it's a little less expensive than the Alpha. Sounds about the same, same componentry. Okay, you would use this in a room that is 40 or 50 feet long. Next size down is called a Rixos L. It's a smaller speaker. It's actually the same size, interestingly enough. They're both 36 inches in height, but we go from an 8-inch depth to a 6-inch depth, and we go from a 3-way speaker with woofers, mid-ranges, and tweeters. We go to a speaker that's actually 2.5-way. There's 2 8-inch woofers and a compression driver, the same compression driver as in the Alpha or the XL in a flat waveguide, and it's $8,500 retail, and it's made to drive a room that's 600 or 700 square feet. So a room that's 30 to 35 feet long, 3 of those across the front, and you'll get the peak sound pressure levels that'll make you rock out, play a movie without any distortion. Now it is called a 2.5-way, and I explain this because it shows a little bit the obsession we have with even distribution of sound in a room. If you put 2 8-inch woofers in a cabinet like this and connect an amplifier to them, at low frequency they're going to radiate evenly as a bubble, but as you go up in frequency they're going to start to create a beam with some interference lobes vertically. And those interference lobes come from the fact that those 2 8-inch woofers are separated this far from each other, and if you're right in front of them you're getting the sound at the same time, but if you're below them, one is closer to you than the other. If you're above them, this one's closer to you than the other. And by being closer, the waves from that woofer hit you before the other one. At low frequency, it doesn't matter because the waves are long. They're 10 or 15 feet long. But when you get to a point where the wave may be 1 foot long, which is 1 kilohertz, right in the middle of the listening area, at 1 kilohertz, when the wave's this long and you're down here, you could be at a place where the wave from this is a half a wavelength away from the woofer that's trailing. And when they're a half a wave away from each other, there's a cancellation. That's called an interference lobing. Sometimes it's known as comb filtering, picket fencing, but it's a big problem in speakers, and a lot of manufacturers make these speakers with all these drivers laid out this way and that way, and they pay no attention to it. You listen this way, they sound good. You go off axis, and suddenly you have holes in the sound. Cannot do that. That is not acceptable. That does not allow your friends to sit over here and you to sit here and you both rock out. It doesn't work. So on the speaker, we actually drive the 2 woofers together at low frequency, and right before they're going to start to create lobes because of the distance between the speakers, we cut off one of the woofers, and you're left with the other one acting as a mid-range, and then that continues on up to the tweeter. And the crossover is very sharp at the lowest frequency we can do, which is at about 1 kilohertz. And that means that vertically, as you go up and down from the speaker, the sound does not change. And horizontally, the sound doesn't change. So that's how we get the thing I call the sound power. This is even bubble of sound, so that in all directions the sound is very constant and very consistent. What does it take to build a 2.5-way speaker instead of two-way? In the case of an amplified speaker, this is actually 3 different power amps. Costs more money. Why do people not all do this? Money. If you ever have questions about stuff, follow the money. You'll figure out what's going on. So this speaker.
I can interrupt you. You use this term amps very loosely. It's like Ferraris, you know? Like, it's not just any amp. Like, let's be honest here. It's one of the best amps you can buy. And the amount of wattage we're talking about is, like, unheard of.
Yeah.
It's at the highest level.
So yeah, I'll talk about, I guess now's as good of a time as anything else to talk about the amplification we're doing. We did at the beginning of this program 5 years ago, we spent a lot of time figuring out what are we going to choose for electronics. Are we going to design our own amps? Are we going to use somebody else's? We found this company in Europe called PowerSoft that has a whole ecosystem of digital signal processing and amplification. In the pro audio business, PowerSoft is considered the Rolls-Royce, like the high end of amplification. In the residential space, nobody's ever heard of them because it's a different business. But if you talk to any pro audio speaker manufacturer or professional audio installer or integrator, they're going to go, PowerSoft, whoa, I'm not worthy. It's like, why? Because it's expensive. It works well. It's also really reliable. You used the word Ferrari a little second ago. It is like a Ferrari with the reliability of a Toyota.
Yeah.
It's amazing. Although Ferraris have gotten a lot better. So this is actually showing the amplifier that comes with the speaker. This happens to be what's called a Mezzo 604, which is a 600-watt brick that has 4 outputs. We're only using 3 of them. And powers this thing up. Now I'm going to geek out a little bit on those amplifiers. The Mezzo line from PowerSoft, I use the word brick. It's really interesting technology. Here's a block of 600 watts. It has 4 channels of output. If you use one only, you get all 600 watts out of that one port. If you use 2 of them equally, you'll get 300 and 300. Very cool. If you use all 4 at the same time, you get 150 per channel. Now, on a interesting thing is on a multi-way speaker like this, never are you going to get all 3 of these devices pulling the same power at the same time. Depending on the program material, one's going to pull more of the other. And so the amplifier is always power sharing between the different outputs to deliver all of its available 600 watts, which is an amazing technology. Really very, very cool. So each one of these speakers comes with an amplifier that's designed to drive it. It gets pre-programmed to drive the speaker. And one of the differences between the Rixos line and the Alpha speaker, we used to make a Beta and a Delta and a bunch of different ones. We also used to make an Omicron, but we stopped making that. Okay? Like, forget that. But all our first line of speakers, the amplifiers were all built inside the box, which is great because it's all integrated. Except that when you want to put them in a wall, you're not allowed to do that. Or in a ceiling, you're not allowed to do that for electrical safety purposes. So the Rixos line, all the amplifiers are outboard, and you're going to connect either a 14.4 from the amp to the speaker or a 14.6 in this case, because this is a 3-way speaker, really. It's 2.5. It takes 3 different connections. So those amps are half rack wide. You put 2 of them side by side. In the case of the 604s, you get 8 channels of 1,200 watts, if you want to think of it that way, as a 1U high with two bricks side by side. And they get connected, if we can, with AES 67, also known sometimes as, or Dante is one variant of that. The connection can be super simple, but you got to remember that when you're pre-wiring with any of our gear, you got to think that the tweeter is getting one signal, the woofer is getting a different signal. If it's a 3-way speaker, the mid-range is getting a different signal. So you got to plan ahead to be running 14.4 or 14.6 to the speaker. If the run is short enough, you can do 16.4. If it's really long, you may need to go up to 12 gauge. But it's not quite the same rules as you're used to from traditional recommendations. Our tweeters and woofers are higher impedance and have a much flatter impedance curve, so you can often get away with running a 16 gauge where a regular speaker, that would have just shot the sound quality of the speaker. If you want to know what you should be running, pick up that thing that's called a phone, you know, like my old style. Call us and go, or send us an email. I'm working on this project. The rack's over here. Speakers are over there. Wire run's going to be about 120 feet. What do you think I should do for wire? Calculator. 16 gauge will work, or 14 gauge, or 12 gauge will help you out with that. All right. So I've talked about the XL. I've talked about the L. I'm going to talk about the M. I think you may detect a trend here. The big speaker is called the XL. Next one down is the L, M. Guess what's going to happen after that? I don't know. We'll see. So the M is a 36-inch tall speaker that's 4 inches deep, dual 6.5-inch woofers. We switch out of a compression driver to a silk dome, a high-efficiency silk dome on this one. And it's designed to drive a room that's up to about 450 or 500 square feet. So a room that's like 25 foot long, you put 3 of those across the front, they will crank. And they play remarkably loud for how small they are. So technologically, very similar to everything else I've talked about: waveguide, tweeter, woofers, amplifier external. In the case of the M's, what we often do is we have a 4-channel amp to drive the left and right pair, 600 watts for that pair, and then a smaller one, a 300 watt for just the center one, which is a 2-channel version. Now the M comes in 2 variants: the tall and really shallow version, or the slightly smaller, or actually quite a bit smaller, this is 22 inches tall, and deeper box. So this thing is about 6 inches deep and 22 inches tall. Which one do you choose? They sound exactly the same. You pick based on your footprint. So let's say you have a room in which you have the depth to go out to 6 inches because you got 2x6 wall, or you have that much room behind the screen if you're doing an acoustically transparent version, but you don't have the height because it's interfering with something. You can switch to the MD. Essentially the same speaker, same price, same sound quality, just a different form factor. In the cabinet, the internal volume is the same, so the sound quality is absolutely identical.
So you can mix and match all of those. That's the point.
Yeah, you could put an MD in the center. You could put an MD in the left and center and have an M on the right. You can mix and match them. The amplitude and phase response of these things is all the same. They're kind of transparent that way. All right, finally in the size range, we finally get to the next level down. So XL, L, M, and then S. We don't yet have an extra small. Maybe that'll happen for Michael's like little mini speaker. But the S, I mean, if these pictures are all aligned so you can actually see the progression, right? So here's the L, here's the M, here's the MD, it's shorter, here's the S. So the S is single woofer, same tweeter as the M, waveguide, built-in EQ into the amp, and it's a smaller amplifier because we don't need quite the same amount of power. Where do you use this? So if you have a client in a room that's about, let's say they have a room that's like 17 or 18 feet long, up to 20 at the max, you can use those across the front. They'll play loud enough. And certainly for sides and backs in a room up to about 500 square feet, that will be plenty of sound pressure level for the surround channels.
I think one thing
That's Michael.
I wanted to add is that I think looking at these speakers, as someone that designs and installs them, sometimes you're like, hey, I'm gonna go get the biggest, baddest one, and that all sounds great, and it's an ego thing.
Yeah.
But the reality is something that I learned. It wasn't that one was better than the other. It was a different tool. One was intended for a larger room, and it was not about it sounded better. They all sounded amazing, and that was the thing that was constantly being driven into us. It was about a constant sound. It's about being able to recreate that sound no matter what the space looked like.
Yeah, thanks for bringing it up. Man, I should be buying you a really nice coffee because you're helping me through this. The sound quality difference between this is nil. They sound the same. You can put them all side by side and play the sound. They're built on the same concepts, using the same amplifiers, similar drivers. They all have the same quality. It's just that the smaller one doesn't play as loud as the big one. That's it. That's the only difference. So it's like those of you guys or gals who are into cars, you can get a really well-designed 2-liter car or a 3-liter engine or a 4-liter engine or a 5-liter engine, and it could all be made by the same factory, just one has more horsepower than the other. Just equally good. They just are differences in horsepower. So if you have a small room or a client that doesn't listen loud, by the way, you could put these across the front of a room that's 25 foot long if you've assessed that the client is somebody that's like, look, we just never play it loud. Why sell them something that's like huge if they're never going to use it? You know, take that budget and put it into something else, a better projector, better control system, something that is actually tied to their needs. And
doing theaters is easy.
Doing theaters is easy.
Let's get hard.
Let's get hard.
Let's talk about where this product is. Why use it? Like,
Well,
we're out in the abyss doing where we are where we shouldn't be.
Yeah.
We're supposed to be recreating amazing sound.
Well, so that's interesting. I think a little later I'm going to talk about case studies where you go, okay, well, so, and it is just like that. Doing theaters is easy. A dedicated room with one door, no windows, no interferences. It's almost unfair these days. Actually, to do it well, it still takes work. You know, it takes months of work. But how do you, in a mixed-use environment where you've got windows over here and a stairway over there, it's all open, it's all echoey, how do you end up producing something where the client can also go, I just hit play and I'm totally sucked into this movie? That's hard. That's really hard. So we'll talk about that. Thanks for bringing that up. So the Rixos S has a little variant called a Rixos SND, which is the same componentry, but the cabinet's reconfigured to be as short as possible, as narrow as possible. It's just a little deeper. So we go from a 4-inch cabinet to a 6-inch cabinet, and that's what's sitting here. This is a pair of Rixos SNDs sitting on top of our smallest subwoofer, which I'll describe in a second. But what I wanted to do is just play a tiny little demo of something on these guys, just so you can actually hear it. So what was I playing when you guys walked in? I think it was this. All right, so I'm just going to play a little track. It's very ambient. It's got really good bass. I'll just start off at kind of a low level. So what I'd like you to notice is Michael's sitting in the nice sweet spot, so he's hearing this singer right in the middle. But for you who are like almost in front of that speaker, where does it image? Is it completely collapsed or does it stay in the middle? Yeah, it's pretty well centered, right? So. And it's been quite a while. So. Sounds okay, right? I mean, this room is untreated. This is an echoey space. Definitely not a dedicated listening room. We've got I know I'm totally off camera here, but we've got an acoustic ceiling. This is not a reference environment yet. With a little tuning, it sounds pretty good. For you, you're sitting on the other side of the room? Does the sound all collapsed in front of this speaker, or does it sound like there's a sound stage in the middle?
We have the sweet.
You have the sweet spot. Okay, and that's not, I use this thing, that's not normal. Normally, everything collapses to the direction where you're sitting. And because of the design of these speakers with the waveguide, which its job is to light up the room as evenly as possible, you don't lose everything there. You don't lose everything there. You're not forced to sit in the middle. Now I'm going to do this other thing, which is to go, well, here's a small speaker. And let's hear how loud it plays in this room. You tell her lies, and she must never know. So that's our smallest speaker in a room that's, what is it, about 30 feet? It's about 35. So this is a room that's 35 by about 20, more or less. 22. Okay, so we have a room that's over 600 square feet. I told you earlier this speaker is designed to play in a room up to about 400 or 350 or 400 square feet. Yet as a stereo pair in a room that's twice the size for it, is it pretty loud?
Oh, yeah.
Pretty loud.
I think the bass response I think you really see the difference when you get consumer grade audio it has this weird fake punchiness at times, which is almost giving. It's like the McDonald's of sound. You know, you think you're getting something good, but you're probably dying. So,
Okay, for the record, thank goodness, in the stuff we do, nobody's going to die.
Yeah.
Right? We can obsess over it, but as opposed to bad food where you're killing people, we're not. But you're right, I know what you mean. Sometimes these things are made with this artificial sweetness that's just wrong. And when you start to play enough program material in it, you switch from this to some jazz, some rock, some that, you start to notice where it's like, dude, there's like this layer of imitation saccharine over everything. Like, what's going on? And we don't want that. Everything is built to be neutral.
I gotta confess, when you shipped us the demos, I was out of the office and Josh and Jason set them up, and I walked in and said, we set up the Rixos stuff. So I dropped what I was doing and ran over here. And the first thing I did was play them as loud as I can possibly play them.
Thank you.
And I just could not get them to distort or crack or break or.
Thank you.
It was just absolutely amazing.
Yeah. Yeah, I know that is amazing. So, again, credits due where it's due. Manny, our chief engineer, has figured all this out. I help along where I can, but that's all his genius in knowing, what drivers do you pick, what amplifiers do you pick, where do you set how do you do all this so that they sound good and you just can't break them.
The bad news is I'm not giving them back.
Uh-oh.
You know what I really like about Manny? That really kind of really.
Other than he's a 12th degree black belt, and we don't want to mess with him.
Up and has the greatest curly hair I've ever seen. I love the guy. No, but all jokes aside, he's the humblest man, nicest guy, and you can talk to him.
Yeah.
And he still has that childlike curiosity, which I try to search for in the people I surround myself. That he's genuinely excited looking at it, and I remember just sitting there with him. We're like Dumb and Dumber, just like stuck on it, in love with it, and he's all about the entire thing, and it's really awesome when you meet people like that. Both of you are. And it comes out in the product. You see it.
Yeah, thank you. That endless curiosity is important, I think, in life in general. So let's not talk about speakers. The people who by the time they're 40 have figured it all out. You can't. You need to live 300 years before you start to figure out 1/10 of what our world is. There's a lot out there. You stay curious. Different countries, different cultures, different foods, different things. It makes life spicy all the way until that day where finally your expiration date has shown up and you're going to poop out, because we all do. And if you can keep it curious all the way till the end, it's amazing. And we're lucky that we're working with sound systems where we can keep exploring. Like, what about this? And check out. Hey, I'm in his office all the time. Manny, did you see this research report from blah 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 in Denmark? And then we're like pouring over. It's like, wow, check that out. It's fun. So there's still a lot. In our particular case, there's still a lot to be understood about speakers. And about how they work and why they work. And I've had this experience of taking this same exact demo kit to 20 different rooms, right? And notice how in every room they sound different, they work differently, and you tune them differently, and everything's a little different. And how do we get to a point where we understand the consistency? We're working towards consistency. And this is less different than other people's speakers, but every room interacts with how the bubble of the speaker comes out and bounces around differently. And how do we learn about that? So we're all about that. I collect data on this laptop. Every project I do, there's like this entire set of what's called impulse responses where we can analyze, well, how did that get back to the microphone, and what's going on here, what's going on there, and what did it take in this particular room to tune it to where it sounded good relative to the acoustics of the room. Now I wish I had time to produce that all into a cohesive data package and present it. But I got data on about 1,000 different rooms and how they behave, and the curiosity would be like, how do you make something that is essentially room independent? So speaker designers worry about this. We want to make speakers that whether you play them here or there or here or there, they always sound the same. They will never do that. But there's ways to smooth them out, equalize them, make them be tailorable to every room. That's part of what we do in here.
Well, if I may ask one more question.
You may.
One more in this minute. Now, you know, you do all these great things, and it's great. It's like having an actual NBA player and then being able to ask them, like, what is your favorite ball? What's your favorite sneaker? What testing tools are you using to do these rooms?
So this this is very cool. So the answer 20 years ago would have been about $20,000 of stuff that I'm carrying around in 3 different really heavy cases that I have to like baby very carefully because it's expensive and fragile. Those days are over. So I'm holding in my hand a Dayton Audio UMM6 microphone, $70. So you can buy one of these and a relatively long USB cable. Actually, this long USB cord costs a third of the microphone, which is funny. And plug this into a laptop and use what's called Room EQ Wizard, which is a really, really powerful measurement tool that you can download free, but I'm going to beg you to send the designer $50 as a donation for every download you do because he deserves it. He's an amazing engineer. He's done a great job. And here's a killer measurement tool for room acoustics. So that's the basics. People want to do this. You know, they're like, well, I have an application on my phone that I can do it. Your phone? Let's get serious. You're gonna program everything from your phone? No. Get a laptop. Do the right work. Just do it correctly. Take the time to put up a mic on a mic stand. Don't hold the phone over here while you're trying to equalize for the ears over here. Just put it on a proper mic stand and do the right job. The next step is you get 4 of these microphones. And you plug them into a little switcher so you can measure 4 locations in the room. When I do the work correctly, and right now sitting out in my car is a case with 4 of these microphones, a switcher, a bunch of cables and stuff to do a better job. But one of these mics, here I'm going to do a little show and tell. Check this out. This here is a mic stand. You guys recognize this? What does this cost? 25 bucks?
Yeah.
If that much. Actually, with the boom, it's maybe $22. So here's what I do, and we did that over here when you guys were just getting here. We did a little calibration, and I'll show you how we do that. If you actually go to the expense of buying the mic for $70 or $80, the long internally powered, with a little dongle USB cable with a repeater for 25 bucks. I feel like I'm in an infomercial. 25 bucks right now. Call 1-800 Good Sound. So you buy this, and then you buy a $20 mic stand. You can do this. You can actually spin the boom around, and you get what's called a spatial average. Hold on one second. I got to set this up correctly. Bear with me.
This was cool. We actually got to see this.
We got to see this. So in room measurements, we call this spatial averaging, which is an average in space. But you just do this really slowly and evenly, and now instead of just measuring one little spot in space, you're getting a nice arc of the listening area. And if you extend the boom longer, you get a bigger arc. Now, this is not as precise as having the 4 mics correctly located and consistently in one place. But man, this is a lot less to carry around than the suitcase full of wires and cables and mics and adapters and all this stuff. So that's the next level. So level 1 is get one of these mics, get yourself a laptop, download Room EQ Wizard, and go at it. Now, going at it means to know what you're measuring and what you're correcting, and later we're going to get into that. But this is a really, really simple and basic tool that everybody in the industry doing home theater audio installation, even if you're just doing little ceiling speakers, if you can actually drive them from one of the boxes that has digital signal processing and EQ, you can correct for the acoustics of the room. So people don't always realize that, for example, a lot of the Crestron ecosystems out there have built-in EQ. You just got to go into the toolbox and you can actually correct from room to room. You can use these PowerSoft amplifiers in upscale multi-room systems. They don't cost that much. They're good quality, but $2,000 will get you 8 channels of 150 watts a channel with digital signal processing. And you can actually set up a multi-room house where you measure the living room and you do this, and then you go into the power soft amp with your laptop and you correct it. You go to the next room and you make it sound the same. You go to the next room and you make it sound the same. Then when the client's walking back and forth in their house, whether it's just background music or party time, every room sounds consistent. They love that. You know, they can turn up the volume on their control system to like level 7 and it's the same everywhere. And you should be doing that. For the right level of client, they deserve that. And the tool you need is simply a mic stand with a boom and a little simple USB test microphone. Don't use just any mic. It has to be made for testing. And this Dayton Audio works very well. There's another mic called a U-mic 1, equally good. The connector on the U-mic 1 is a mini USB, so it's a little fragile and it's hard to get a long extension cord for it, whatever. Okay. If you want to go the next step after that, you get a set of good non-USB mics, but actual omnidirectional test microphones. There's a bunch of companies that make those, and you plug those to a proper preamp and a proper USB converter. That's what I schlep around when I'm going to go do a really good quality work. But all of that is 1/10 the price and 1/4 the weight of what it was 20 years ago. So you should be taking advantage of it. I am going to say something as part of that, which is, so I'm talking about mics and EQ. Like, don't you just put up the mic that comes with the receiver, you push the button and you go? No, you don't. And I have asked literally hundreds of people in our industry, what do you think of all these auto EQ things? Well, we run them. Were you happy with the result? No. Wait, everyone, I actually now wish I had started to tabulate and actually make a survey, and I could show you that 9 out of 10 installers agree that the auto EQ systems, I won't name them by name, I just don't want to go there, but all of the things where you're supposed to put up a mic, plug it in, hit go, don't sound good. And I often hear, well, we tried it, it didn't work, we turned it back off, or it didn't sound great, but we left it on. What are we doing as an industry if we all agree that's not working? Right?
I also have to agree that most of the people don't even know what direction to put the mic.
I tell you what, it's harder it's harder to remember the code of the 8 wires on a Cat 6 cable and knowing how to punch it over time than doing this. And knowing how to flip the wire. Everybody knows how to do that. Everybody's learned how to do that.
No, but even the direction of the microphone, even the way you stood it up and put it up, I have seen more companies push that mic into different directions and be like, well, what is it that you're doing?
Yeah.
Yeah, they pointed, it's a wand, it's, I don't know what's going on.
It's simply, it's an omnidirectional mic, so it doesn't really matter which way you're pointing it. It's picking up a globe of sound all the way around it.
But do you point that mic at a speaker?
No, you just point it up at the ceiling because
straight up. Think about that.
It's picking up the same amount here as it is here as it is there. There's 2 different types of Omni mics. There's what's called a pressure mic and a random incidence mic. I won't get too much into it, but you want a random incidence mic. That's what this is, and it almost doesn't matter. And you could try it someday. I don't think we'll have time here, but I'll show you in measuring that speaker. This, no difference. So it doesn't really matter. You just hold it up like that, move the boom around, and off you go. So the point is correct that people don't know what to do with this. Well, people don't know how to drive until they take driver's lessons. And meanwhile, there's millions of people out there that are driving and driving and driving.
I think most importantly, what they forget is that they still have to use their ears once that machine
Okay.
is done doing what it's doing.
So can you guys hear him out there in the world? All right, David had a statement. That's an important statement.
It's very important. Lots of guys, they push the button, the machine finishes, and they walk away.
Yeah.
And that's a big mistake because that machine is not really meant to get you to the finish line anyway. You have to use your ears. And you have to be trained on what to listen to.
Yeah.
So it takes a lot of time.
Yeah.
I mean,
you don't have to be trained.
Those
the training is not that hard. So I have a whole section about the EQ coming up, and I'll support what you just said, David. I agree.
Thank you.
In the end, one, the auto EQ systems don't work very reliably. One, two, they don't have ears. They have a microphone that's supposedly listening like your ears, but I have found repeatedly that you can draw up the most beautiful curve on a computer display, and you put that aside and you listen and you're like, that sounds way too bright, or that sounds completely dull. And you go, well, now what? Now am I going to take my taste and I'm going to compete against the mic? Yes, you will. Now, my little trick, I'll show you this later, is I have a pair of earbuds that a company called Etymotic makes. They're pretty expensive, but I plug that into my phone. I play pink noise into my ear. It's referenced. Those earbuds are really, really, really high quality. They're corrected for what's called a head-related transfer function. So while you're putting right down in your ear, they make it sound like it's coming this way. And I put pink noise on the speaker. I listen to pink noise here, and I compare. If you get to a point where it's close, you're done. How hard is that?
Doesn't seem to be very hard.
It's not hard.
But us as men, we lose hearing. Naturally.
What?
Exactly.
So what Michael said, he doesn't have a mic. Somebody took Michael's mic away.
Very hearing, yeah.
So, correct, but that's irrelevant. You know why? Because this is a comparative test. So Michael said men lose hearing when they get older. We do. More than women do. More than women do. But when...
because we want to.
I think it's because
No,
of
we
women,
actually...
but I didn't say that.
We actually do lose hearing. Interestingly enough, boy, I could go on about this. Let me say this. Our thresholds of hearing get higher, as in it takes more level at some frequencies for us to start to hear them. I'm convinced that once you're past that threshold, you hear just like you always did. And I have a whole bunch of experiments I've done with clients that have really bad documented hearing. Once you get over the level, they're not missing mid-range or high frequency. But the point, though, is in this comparative test, let's say your hearing's all screwy. It's screwy whether you're putting those earbuds in or not. It's a comparative test. And if on that comparative test they sound the same, you're done. You just sold a $300,000 system to somebody, and you're going to hope that the robot that you push the button on with the microphone that's places is going to make that thing shine? No, it does not work that way. That's like saying, I'm going to have you come over to my high-end restaurant and I'm going to serve you an amazing dish, but I never tasted it. I just followed a recipe that I found on the internet that took some frozen foods and stuck it on the microwave. No.
So I have a question then. Is our ultimate goal when tuning a room to come as close to flat as possible?
Okay. So the question is the goal to get as flat as possible? The goal is that at the hearing system of the human being, not as measured by the microphone, at the human system, the level of the bass, the mids, the treble, and everywhere in between is as even as possible. Interestingly enough, when you get to that sensation and you measure with a microphone like that, the curve is going to look like this. It's actually not going to look flat. It's going to look like it's got an emphasis at low frequency, a little bit of a dip, gently descending, and then it's going to roll off at the top end. That's what the net speaker plus room character is going to do with the microphone. So that's a little confusing. If you take that same microphone and you bring it up close to the speaker, hello speaker, you put it right here, you will find flat. But as you move away, flat being that the measured response, as you put even sound into the speaker from bass to mids to treble to where it's a nice smooth line, as you move away from the speaker, it's going to start to do this naturally. Why? Because as you get away like 12 feet, 13, 14 feet from the speaker, what you're getting is more and more of the sound power of the room, as in what's reflected around the room. And if you look at the reverb character of most rooms, they're going to emphasize a little bit more of the bass in most rooms, not all of them. And the high frequency is going to get attenuated because carpets and other things absorb the highs, and also air absorbs the highs.
And why do most manufacturers measure at 1 meter?
So they measure anechoically. They measure the speaker they actually mostly measure at 2 meters and refer it back to 1 meter because most speakers are too big to get a good result. But the measurement is not an in-room measurement, it's a measurement of what the speaker puts out as a bubble of sound. So if you had, let's entertain this differently. If you had a speaker with an anechoic response, as in the measurement without any walls around it, or really a room with 6 feet worth of absorption all the way around it, at 2 meters that's flat, and you listen to it outside without any boundaries, you would hear flat response sound. And the word flat is always a little challenge because people go, flat's not good. I would say smooth, like even sound. You will hear that. When you start to put walls around that speaker, the sound's going to change. And the room is going to have some natural bass boost in it. It's called room gain. And it's going to tilt the overall response of the speaker to where the desirable measured in the far field response in your direction looks more like a shape like this, where it's a little more emphasized at the low end, then a gently descending slope, and then somewhere around 6 or 7 kilohertz, a gentle fall off. So that is the target curve you're looking for in a room, so that when you put the mic away and you listen, you go, yep, that sounds good. Or if you do that pink noise test, yeah, it compares. Now, the problem is every room's got a different reflection character. And every speaker has a different sound power in how it lights up that reflection character. So if you only go, this is really key. Actually, what I'm about to say is incredibly relevant at the highest level of the Audio Engineering Society conferences and discussions. If you rely on a target curve to be the same for every speaker in every room, you will end up with problems and errors. The fine folks at the National Research Council in Canada that then went to the research group at Harman have defined a target ideal response for most speakers in most rooms. So if you take a cross-section of about 50 different speakers in 50 different rooms and you go, what does it take until on average they sound good, you end up with our target response curve, which is the one I described. But you will have rooms, you'll have speakers placed in certain rooms in which that target curve is going to sound either too bright, like too much high end, or too dull. And in fact, yesterday I was in front of one of those where if we have time, I'll bring it up, where what it took for that particular speaker room combination to sound good is a target curve that looked like this, where the high end, it was about 2 or 3 dB higher than what the normal target curve would be. And that's just in that room, that radiation of that speaker, that room reflection, all of that, that's what it took to get there. So that topic of what's sometimes known as the target curve or the house curve is a really complicated one. I'll finish one more thing. With our speakers, with really even sound power, there is less room dependence on that target curve. There still is some. It would be a lie to say it's always going to sound the same. That would be complete BS propaganda. But by starting off with a speaker that radiates in the room very evenly, you've at least taken that error out of the equation. Now you're just down to the room. If you can build a room, if you can design and engineer the room to where the reflection decay time is even at all frequencies, to where when you put a sound in the room, whether it's at 100 hertz or 500 hertz or 2 kilohertz or 8 kilohertz, it decays evenly, now you have a fighting chance that you can just draw a target curve and it's going to sound good. And it's in those rooms that the auto EQ works pretty good. And it's in those rooms where you don't need the auto EQ because the thing starts off being right in the first place. So that's my long little propaganda. Go ahead.
So I was going to say, with regard to field monitoring, using a near-field speaker or near-field design in a theater is wrong. Or would you mix and match?
So that's a whole other topic. There are, in the pro audio side, in the recording studio business, there are speakers that are called near field, midfield, and far field. A speaker doesn't know what field it's in. It doesn't. Manufacturers make speakers that are small, that don't have a lot of sound pressure level, that you need to put 6 or 7 feet away from you, and those are called near fields. Really, they should be called small speakers that don't play very loud. And the far fields are usually a big thing, soffit mounted up here. Those should just be called speakers that play loud. Both of those should have flat response, anechoically, even sound power, and all of that. And there are some manufacturers out there that make very good small near field monitors that are amazing that you can use as a front speaker in a small theater. Really fantastic pro audio speakers. They don't cost that much. They work really well. So, all right, big digression into the business of EQ and stuff, and I'm gonna spend some time on that. Let me finish with the speakers, and then we'll take a little break. Sounds good? Okay. Next in our line of speakers, there's a product called the Rixos W that in fact is a derivative of the Rixos S. So I'll click through that. Look at this guy. Sorry, that didn't work. Look at this guy. Very similar speaker. The difference is that instead of the waveguide being flat on the same axis as the woofer, it's tilted back. What is that for? It is designed so that when you put it up on the ceiling, you can actually use it as the top speakers in an Atmos playback and aim the mids and highs at the listening position.
Oh wow.
So
that's a really important point that you need to go over a little bit.
David is saying that's an important point I should go over a little bit. I'm going to go over it a lot. So this is the point at which I say, us at Grimani Systems, we obsess about radiating the sound to the listener, just making sure everybody's in the sound field. We're sort of in the business of providing showers of sound. And if we produce a shower of sound in which you've got an audience over here and there's a really nice big, those big giant shower heads that make you feel like you're in a tropical storm, but it's raining over here. Are you taking your shower over here? No. You're dry, you're smelly, it's not working, your hair looks like it needs shampoo. So we produce speakers, in this case, in which if the shower head's over here, it's tilted this way and it sprays at you and gives you your shower. How's that for an analogy? So this particular speaker is designed so that you can put the source of sound where the fine folks at Dolby or the cinema screening room designers put the speakers, but in which they usually put a giant speaker that's tilted so that it's aimed at you. So maybe in a movie theater or a recording studio or a dubbing stage, that's okay to have a box that's about this big that's tilted over this way. In the home theaters I work on, there's no room for that. And so I go to rooms all the time designed by people that ask me to come and calibrate them, in which there's a really nice speaker placed right here firing down at the floor. And the first row of seats is right here, and you kind of hear it. And then the second row of seats, it's gone. And at the last row, there's no sound out of that channel. So that's not right. That's just not right. So if you have a scene in a movie in which there's a spaceship that starts on the screen and it goes up this way past you and in the back, if you're sitting over here, you're going to hear it. If you're sitting back there, you're going to go, I don't know, it was here and then it's gone. Oh, and suddenly it shows up in the back speakers again. So there's a hole of sound. That's not good. So we designed the speaker so you can put it where it's got to go, and it's beaming the sound at you. And there's two versions of it. Technologically, it's the same amp, it's the same drivers as a Rixos S. It's tuned differently because by being cocked over, there's a different crossover character. And it comes in a few variants. This is the one that's about 4.5 inches deep. It's designed to be hung from the ceiling with these resilient brackets, and stretch fabric is hiding it. Better home theaters we're working on, there's stretch fabric everywhere hiding all of the gear. Or you just tolerate the fact that there's a black speaker on your black ceiling, you don't really see it. There's a variant of it called the WD that's reformatted. It's a little deeper, it's a little smaller, and there's a flange, an installation flange that goes all the way around it, so you can fully recess it into the ceiling with a grill to hide it, or it can be dropped down about 2 inches or 1.5 inches from the ceiling with a waveguide peering over at you. So if you don't want to do a stretch fabric ceiling that's 4.5 inches deep to hide the speaker, but all you can get is a 2-inch deep solution, that will work great. Then there's a third version of the guy called the WD Plus, which is a same cabinet as this, but with an 8-inch woofer instead of a 6.5. It just plays louder. So for a bigger room, like if you had a room that's 30 or 35 feet long by 25 feet wide, you'd want to have 4 or 6 of these guys to play plenty loud. In a mid-sized room to a small room, this will play plenty loud. This is the same sound pressure level as you just heard from these guys. Loud enough? Okay. So it does surprise people how loud these things crank. David, thanks for bringing that up. We, however, want to make sure there's plenty of headroom, plenty of reliability, and don't ever want to push that engine too hard, too long. We don't want things to blow up.
And my daughter can't push in the speaker.
Doesn't have a little tweeter.
Dome that's going to get broken.
Good point. Okay. Finally, in the Rixos line, we also make a horizontal horizontal speaker. Originally conceived as a center speaker, but it can be used in other applications. So this particular speaker is like a Rixos M, dual woofers, waveguide. They're just reconfigured horizontally. And this is a 2.5-way speaker, without which you would get interference between the two woofers. If we did what everybody else does in their center speakers, the two woofers are playing up to the crossover to the tweeter. Major interference. It sounds good right in front. You go 1 C to the right or to the left, and all the mids are dropped out in a regular speaker. So this thing is driven by 3 channels of amplification. It's 2.5 way. The two woofers start together at low frequency. One drops off. The other one continues on up and then hands over to the tweeter. The crossover to the tweeter is at 1 kilohertz instead of 2 or 3 kilohertz like most speakers. So the off-axis lobing this way is reduced. So I'm talking about this lobing business. Have you ever had a speaker manufacturer sit and talk about lobing and radiation and off-axis? I've never heard anybody talk about that in sales presentation. At speaker design, you talk about it all the time. So in the lab, when you're worrying about how you're designing this thing, you talk about it all the time, but it never comes out into the world. This is one of the most important things in the sound quality of a speaker. And we should talk about it. We should talk about smooth response and good drivers, all of that, the low distortion. That's the easy part. You know, buying a woofer and a tweeter with low distortion and good sound pressure level today is almost trivial. It's just, they're plentiful. You can buy it as a consumer, you can buy it as a manufacturer. They're not that expensive. That's no longer the issue. The issue is the dispersion. Can you make a speaker that's like this wide and sounds the same here as there, and the way it lights up the room is really even? That's where things are hard. So that's why I talk about that. This thing is $5,900, which is fairly pricey for a single channel mono horizontal speaker. And it is that pricey because it's got all the same components we put everywhere else. It's made custom to the size you need. So it comes at any dimension between 38, it's written 78 on here, 34 to 78, but if you wanted a longer one, we could make a longer one. And the concept is it's built to match the width of the TV. So on this picture you see behind here, that room over here has, this was a 75-inch TV and a bar that is 66.5 inch for that one that matched the size of the TV. So the cabinets are custom made. It's a little more expensive. It is a 3-channel amp. It kicks ass. It plays even louder than these little guys because it's got 2 woofers. And along comes a price with that. It's a high quality product.
Lead time.
Sorry?
Lead time.
Lead time is these days is typically 3 months now.
Okay.
It used to be 2. With everything you're hearing about, you know, we like everybody else are dealing with all of the shortages of materials, shipping. Sometimes materials are available, but they can't find a truck to get the materials to us. Whatever, the whole supply chain thing is also affecting us. Our official lead time right now is 3 months. Okay.
Yeah, but you're out there. This guy is like out in the jungle trying to find like who's the next guy making.
Doesn't make a difference. It's still 3 months.
No, but like you just came back from Costa Rica or something to try to figure out a speaker.
Oh, that's an interesting thing. My new propaganda is going to be Argentine wood, isn't it good? So, as part of the supply chain issues in the great America, it's hard to get MDF and plywood in quantity anymore. And the prices have gone up like crazy, the quality's gone down. And I can't deliver speakers that take 6 months to make because we can't get the wood. And I can't deliver speakers that have MDF that when you play sound on it, it's going. So I started to look around at other countries and who's got supply chain that can do this. And I found that in Argentina, they have an extensive wood culture, make beautiful furniture. And I found a factory that is right now, as we speak, assembling cabinets for us in Argentina and with beautiful joinery, great paint job, wonderfully done. And they sound warmer because they're all about tango, you know. No. I should use that propaganda, but I don't think that's going to work. But yeah, all these cabinets are going to be coming from Argentina. This particular model, still made here because it's custom sized. Although I'm convinced that I could probably... American birch. I'm convinced that I could probably still have it made in Argentina and ship it up here by plane faster than it is right now in the U.S. And this is just an issue with supply chain we have temporarily in the country here. Okay, last little things before we break are we make one tower speaker called the Tau, which is technologically a little similar to the M. It's a different driver set, but it's essentially an audiophile speaker, internally powered, beautiful paint job, piano lacquer. You can get it in black, white, or silver. It's actually Audi paint, what we use. It's a really, really strong quality paint. And it's a great sounding speaker. And the use case for that would be a customer like you see on this picture, where they said, I don't want speakers in the wall. Either I don't like the idea of that, or I just don't want to put holes in my wall. I love the idea of a tower speaker that sits in the room. I'll pull it away from the wall. I'll make it sound good, and then we can tune it and equalize it, because there is an EQ system built into the speaker like everything else. Okay, that's the Tau, $10,000 each. It's an audiophile speaker. Michael's heard them.
I'm so intimate with this. I've spent hours just playing, and even it's funny. Like, we have a mutual friend, this guy Noah. Noah's real interesting individual, and he's literally got like whatever speaker you want to play with, and we've been playing with all of it. And these speakers are sitting right in front of another set of very expensive speakers. Not for nothing, these look like it's little brother. But the little brother could clearly beat the crap out of big one. So these sounded so much better, so much cleaner.
Yeah.
Just that sound was perfect, but the finish, the everything. And I mean, I beat on it. We watched movies, we watched everything. And even Noel loved them.
Yeah.
And Noel's a guy who got to listen to everything.
Yeah.
We just kept going back to them. And even in Noel's house, there's several like surround sound systems, and not little things. But yet we went always in that same room, like, let's go listen to those speakers.
Yeah, that listening room is clearly a case of David and Goliath, where in the way we design the speakers, they play, like these little guys, they play way louder and way better than your eyes are telling you this should play.
Oh yeah.
We often get that comment. That sound's coming out of that little guy. You're shitting me. That's not possible. Like, that's what it is. All right. Finally, we have a range of subwoofers, and it's very simple. There's a really big one, made as shallow as we can. It's about 12 inches deep, 18-inch driver, 1500 watt amplifier called the Sigma. We have a next size down that's a dual 13-inch drivers called a Psi. We have the next size down called a Zeta, single 13-inch driver, about 5 inches deep. And finally, we have these little guys you're seeing over here called the Epsilon, 10-inch driver in a relatively small cabinet. Which one's right for the install? Depends on the size of the room and how loud the client likes to play. So we just finished the install of a relatively large, great room in California with 4 of these guys in the ceiling. And the client said, look, I don't play that loud. It'll be fine. And the room itself is probably about 1,000 square feet total. The theater area or the media zone is on one end of the room. And 4 of these in his ceiling cranks plenty loud for what he wants to do. And sometimes we have rooms that are smaller, but we know the client is kind of like Noel and wants to crank it up and loves really, really big, loud bass. And so we'll put bigger subwoofers in there just because we know they just love really loud bass. So you need to know that. You can't just go, this subwoofer works for everything. You got to match the room size and the client's needs for how loud they like to play low frequency. Okay, so I propose that we take a quick break. Coffee, bagels, bathroom break, and we'll come back and talk about the technologies that are inside here. And I like the way we're interleaving a discussion of the product and, ooh, you guys can't see, pizza. Bring that over here. I talked about bagels, but
Because we know you're watching your diet. We got you the vegetable.
this one is for me only. I don't know what you guys are eating. So no, I like that we're interleaving stories and talking about technologies and general conversation about room design and speaker design. This is what makes it interesting. So thank you guys. We'll come back in a few minutes. All right.
Sugar, when I rise. Said it's early in the morning. Sugar, when sugar, when you done living in misery, bird. You done living in misery. Arise, 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 arise. Still arise. Arise, 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 arise. Arise, 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 arise. Still arise. Arise, 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 arise. Mama, 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 rise. Mama, 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 rise. Mama, mama, mama. Told you I ain't been in Georgia. Ever done told a dirty lie. Told you I ain't been in Georgia. And the eagle on the dollar, unlike the eagle on the dollar. You done living in misery, bird. You done living in misery. You done living in misery, bird. When you rise. Mama, 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 rise. Mama, 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 rise. Mama, mama, mama. Mama, 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 rise. Mama, 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 rise. Mama, 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 rise. Mama, mama, mama. And the people went into their high hour. From the start, they didn't know exactly why. Winter came and made it so. Look alike. Underneath the grass would grow, aiming at the sky. It was swift, it was just another wave of a miracle. But no one, nothing at all, will go for the kill. If they called on every soul in the land, on the moon, only then would they know a blessing in disguise. There were nights and mornings when you clung to me, found your way into my bones, my joints, and into my veins. Like an animal, you coiled your darkness around me. You spelled your name in charcoal all over my body. But these days, I just walk with you. These days, I'll let you stay. A little further away, but I'll walk with you. These days, I'll let you stay. There were summer days and nights when I was blind to you. You were quiet and you were still, even when the moon was full. My temporary state of lightness would scare me. After all, I was sure you were more strong than I was daring. But these days, I just walk with you. These days, I'll let you stay. These days, I just talk with you. These days, I'll let you stay. A little further away, but I'll walk with you. These days, I'll let you stay. The things you've shown me over the years, the roads you blocked, and how you define me. These days, I just walk with you. These days, I'll let you stay. These days, I just talk with you. These days, 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 these When you dream, you only dream you're Annabelle. All the secrets there inside you, Annabelle. Born beneath an emerald sky, Saint Annabelle.
Feel ashamed, you're a knowledgeable, nasty expert in the game. I know you're gonna do it with an easy touch. Knowledgeable lady, you love as such. I know you're never ever gonna feel ashamed. You're a knowledgeable, nasty expert in the game. I know you're gonna do it with an easy touch. Knowledgeable lady, you love as such. I know you're never ever gonna feel ashamed. You're a knowledgeable, nasty expert in the game.
Never know how much I love you. Never know how much I care. When you put your arms around me, I get a fever that's so hard to bear. You give me fever when you kiss me, fever when you hold me tight. Fever in the morning, a fever all through the night. Sun lights up the daytime, moon lights up the night. I light up when you call my name, and you know I'm gonna treat you right. You give me fever when you kiss me, fever when you hold me tight. Fever in the morning, a fever all through the night. Everybody's got the fever, that is something you all know. Fever isn't such a new thing, fever started long ago. Romeo.
Tell me when we're live. Okay. And we're back live from Plainville, New York. Plainview, New York. All right, are we all back here? Great. Well, we're back from our little pizza fest. I was playing a little Stevie Ray Vaughan. How did that sound?
Sounded great.
Pretty good. So for the record, I was playing that while I have that as a high quality rip from a CD on my laptop, and I normally would play that as a direct digital connection from the laptop to the speakers and have that be the path. Right now, just to show what you can get away with, I was actually playing it from Tidal. That has pretty decent quality onto the laptop, and then the hop from the laptop to the speakers was a Bluetooth transmission. Wow. You would not expect it to be able to do that. Now, Bluetooth, when it first came out, was a low bit rate technology for a mouse and a keyboard. It's evolved over time to be a much higher bandwidth and much better transmission algorithms. And so what I'm actually using right now is I was going to say little, not so little, Denon branded balanced output Bluetooth receiver that's using the latest aptX technology, and that's what it's transmitting from my laptop, so it can sound that good. Why am I telling you this? Because if a client wants good sound and they're thinking, no, the only way to get good sound is to have a rip of high definition audio and it's all going to be wired. It's like, well, yeah, that used to be the way. Today, as long as you set it up correctly, you can just use Bluetooth from a phone or Wi-Fi from a phone, because there's Wi-Fi technologies available now that have one benefit, I'll get to that into a second, into a whole house distribution system, and as long as there's good speakers with good dispersion and good tuning, it could sound this good. A benefit of the Wi-Fi approaches is you're not limited by the length of Bluetooth, which is about 30 feet. Somewhere around 30 feet it starts to break down. And with Wi-Fi, as long as you're on the network, you can actually keep playing it. And there's several Wi-Fi oriented technologies out there that allow you to do that. Okay? Any questions from what I was covering earlier today?
How come on the subs you have a piston design for the speaker and not your more traditional speaker?
This particular sub here?
Correct.
So the question was, those of you who didn't have So why is this a flat diaphragm? This particular driver is built that way. There's a bunch of companies that have been doing that, so sort of a carbon fiber membrane in the front. If you actually took the driver out, you'd see that it's still, the basket is still conical. It's just a face, instead of being the visible cone, has a flat diaphragm. That's just how that driver is built. It's not, we didn't specifically say we want a flat diaphragm. It's just that for a 10-inch driver, that's a really nice driver for the size, the weight, and the money. You'll see that driver in a lot of recording studio speakers, interestingly enough. Okay, so before the break, we talked about what our mission is and what the products are. As a reminder, the mission is to get to audio excellence with better ease, better quality, better reliability. And in our view, audio excellence is being able to reproduce the exact sound you hear in a film dubbing stage, an environment where the films are being mixed, or a recording studio. That's our reference. Without that, it's all very subjective. It's like, well, I like it more this way or that way. It's like, well, tastes are okay, but there is a standard of what you're supposed to be hearing. So we call that audio excellence in a way, is to get to that place where it sounds as good as it did in the mix stage in a film studio where the movie was being made, or as good as the recording studio where the thing was being recorded. So next up, I'm going to talk about the technologies that make all this work. So the first core thing that makes us quite different to a lot of other speaker manufacturers is this obsession about sound distribution, sound power, the bubble of acoustic energy that comes out of the speaker, and it wanting to be, or we wanting it to be as even as possible from left to right and from top to bottom. That's a thing that's been known in speaker design as important, but we found that people don't, there's some lip service paid to that in different manufacturers, but in most cases, when you actually look at what they've done, there's still a pretty strong hotspot. And what I mean by that is if you listen right in front of the speaker and then you just move over here, you can hear that it changes. One of my favorite way to do this is to play what's called pink noise. It sounds like static into the speaker. It just goes shh. And because it's not changing, it's this continuous sound of like rushing water, you can hear how the sound changes as you move back and forth. And you'll find that most speakers have a pretty serious hotspot in front of them. And as long as you're right in front of the speaker, maybe that's okay. In a home theater, nobody's right in front of the speaker. You've got 20 people sitting at different places, and that's a problem. So we obsess about sound power. We think it's really, really, really important. And I'm going to give you a quick backgrounder on what that means. And what I'm about to show you here is stuff that's important for all speakers. This is not just propaganda for our product line, but this is a little educational session on what it is you should be looking for when you're picking speakers. What's really important is to have smooth sound power at all the seats. I think intellectually now you can kind of understand that. If I was a speaker, I'd want to make sure that you hear, all you guys hear the same quality of sound, the same response of sound. Sorry, you're there too, the whole thing. And actually in these speakers are even over plus and minus about 70 degrees, which is huge. So over 140 degree arc, there's essentially no change of sound. And if you guys want to hear that, maybe at the next break, I'll just put some pink noise up on that speaker and you can just kind of walk around and go, okay, no change, no change, no change, no change. Wow, there's like no difference. And that is one of the reasons why it sounds so good in here is that you're hearing a really nice direct sound from the speaker, but also the boundaries in the room, everything that's bouncing around is the same response. It's really even. What your ear is hearing is one direct sound that's one thing, and then a reflected sound that's the same character with no variation, and that just means I like it. That's immersion. That feels like you're bathing in really nice sound from the direct and the reflected sound character.
If I can ask a quick question. Now, I heard you say the term pink noise. Now, that might be a term, you also hear white noise. Like, what is that?
So, Pink Noise is my favorite band. They had all these hits in the 70s. There's this song they had called The Dark Side of the Room. It was amazing.
Hold on, I got something for that.
I'm gonna play you those two things. So rather than just explain it, I'm going to play it. They also had another cut that was called "Wish You Could Hear." Remember that one? So this is Pink Noise. It's going to play in the left channel only, as long as I turn the volume back up. It's got a pretty good beat, right? And then I'm going to play white noise. So you hear the difference between those two, right? So white noise is very hissy, and pink noise is more full. White noise is equal voltage, equal amplitude at all frequencies. If you actually put that on a spectrum analysis and you looked at the value of what happens at 1 kilohertz as a single tone, or it's all equal. But to the human ear that listens with less sensitivity at low frequency than higher frequency, it just sounds really imbalanced and hissy. Pink noise is white noise. It's actually been put on a filter that tilts it this way. It actually changes the balance of it to where it emphasizes the low frequency and turns down the highs. And it's called pink because if you put the same shape on white light, it would make it look pink.
Nice.
Did you know that? Cool. That information and $5 will buy you a coffee. So it's a small one, yeah. So pink because in light, the lower frequencies are in the red, the higher frequencies are in the blue, in light. And if you were to actually shape light to produce a pink light out of that, it would be you could actually trace the shape of that. It turns out technically it's a filter that attenuates 3 dB per octave. So every doubling of frequency, it's 3 dB quieter. So that's what pink noise is. Now, the reason we use pink noise in the audio industry is a bunch of reasons. And some of it is a tail and a dog wag, like who started what. First of all, I will say that pink noise sounds more like music to our ears. And I probably don't have time. I can digress for hours on this stuff. But if I put pink noise up on the speaker and measure it, put it aside, and then play a cut of music that we all agree, yeah, it sounds nice and full, and you look at it, it's like, wow, it looks like the same spectrum. It just turns out that the way we like music to sound has a fullness and a richness that happens to have the same shape as pink noise. That's not why that was invented. Pink noise also allows you to make filters, actually, that are in third octave or octave bands that have the same character, and then take the output of that filter and put it to a little voltmeter, and it will... Sorry, I'm not available right now.
I thought your voltmeter was going off.
My voltmeter is going off. If you put pink noise into what's called a real-time analyzer, which is made out of voltmeter, but with these bands that are all equal third octave or octave energy, it'll come up flat. It'll come out equal. Because as you're going up in energy, there's more and more frequencies in each band, and so the value of that filter has a higher voltage. So if you put white noise into a bank of third octave filters, all the same size, it's going to look like this. It's going to look emphasized on the top end. You put pink noise in, it comes out flat. So pink noise ended up being made as a source for a real-time analyzer. So you could actually just do these constant third octave bands and end up with something that looked flat when it was supposed to be flat. It just turns out that it sounds more like what we're used to in music and measures more. So everybody uses pink noise in the audio business for analysis and tests and things like that. And if you use pink noise, if you get used to what it sounds like, if you get used to what it sounds like over Redford's headphones, it's an amazing tool, really amazing tool. So does that answer your question?
Yes, yes.
Okay. All right. So now, in the piece of software I like to use, there's the dance club version of pink noise. So that one actually has a beat, and this is called pseudo-random pink noise. It's I have it set for 32,000 cycles now, or 32,000 tones. This is actually 32,000 individual frequencies playing in a cycle that's so fast that you don't hear the individual frequencies, but there's a return to the cycle. That's where you hear the... What's that for? Well, for analysis purposes, it's because rather than be random noise, it's individual frequencies, the analyzer can quickly latch on that and give you a result for the measured spectrum that's a lot quicker. And so when I'm doing analysis, I use what's called pink PN on here, pseudo-random pink noise with the analyzer that's in Room EQ Wizard. I know I'm going off on a total tangent, but any of you guys selling any audio to anybody that's above $300, you should know this. You should know how to use a microphone, how to use a simple beat-up laptop like the one I have, and know how to measure and tune the room until it sounds good.
Is this, as a dealer, something that we can sign up with you guys to show us more how to do this in the rooms?
Absolutely. So there's two ways to do this. Let me bring this back up. Did not mean to do that. Hold on one second, Mike.
No worries, take your time. Wait, taking a picture of it, Tony? Ordering one for everyone?
You got me use the card.
Go for it, bro. Everybody, we're about to sign up everybody for trading.
All right. So your question is, well, how do I learn how to do this? Part of the training for a dealer is to, if you want to learn, we can teach you how to tune and how to calibrate. Other possibilities to go, I don't have time for that. You guys, I'll hire you guys to come on over and tune the rooms, however you want to do it. And I do in my daily day, I'll do everything from design and build and tune our speakers to go and design rooms around other people's speakers and tune those ones. So like yesterday and the day before, I was working on sound systems from a totally different company that are decent speakers, tune those to where they sounded good in the room. So you can do that all the way around. All right, So what matters for speaker sound quality is even sound power. That's been known to be an important thing. As part of that, the speaker needs to have a smooth axial response, so that's the sound directly from the speaker to your ear, and also have a smooth off-axis response. These two things together, when you take them far enough, all the way off-axis, give you a smooth sound power. So for a speaker to sound good, and I'm going to tell you, as opposed to spreading propaganda that's unsubstantiated, I'm going to try to give you some proofs of these things. Because so in communication in the media today, there's so much BS spewed across so many different places. It's actually kind of sickening. I feel like our society should be going more towards truth and away from randomness. But on the audio side, I'm going to say these three things. A speaker sounds good when it has good axial response, good off-axis response, and good sound power. How do I prove that? Well, there's a guy called Dr. Floyd Toole that's made it his life's mission. He was a president of the Audio Engineering Society. He was a director of the Acoustics Research Center, Acoustics Department of the National Research Center. And he's put his whole career into figuring this out. And he has hundreds and hundreds and hundreds of data points on what people think sounds good. So he and his team have put people in front of speakers that have good and bad frequency response, good and bad axial off-axis response, good and bad sound power, and has shown that most people, without knowing what they're listening to, without looking at the data, go, I like the way that speaker sounds better than this. And when you look at that, that is usually a speaker that's got good notes on this, good grades on this. So that's what we design, is speakers that have very good response on all three of those. You may as well have low distortion too. There's been an obsession around distortion over years, and it turns out that as long as you can make a speaker that's, below 2% or 1% distortion, most people are going to be happy with it. If you want really high quality, you got to try to stay below 0.5%, but you'd be amazed what the human ear will tolerate in terms of distortion. So while it's nice to have really low distortion drivers, that's not the first place to obsess. First place is to have good direct sound, good off-axis sound, and good sound power. That will make speakers that sound better. You also want a speaker that plays as loud as you would want it to play. So some of our clients may not ever want to listen loud. Like what I played in here earlier would make some of my clients just run out of the room and call 911. And other ones go, that's all you got? So they come in different sizes and shapes, our clients. And you got to try to figure out how loud do they want to play and match the speaker to that. How do you figure that out? You ask them, do you like to play loud? And if they say yes, what does that mean? So my favorite trick is I bring the client into our showroom, I play a little stuff, and then I go, here. I give them the remote control, and I go, turn the up-down volume up to the loudest you would ever want to play. And our room is calibrated in decibels. When they go up 5 decibel from reference or down 10 decibel from reference, I can tell you within a dB what the voltages are that the speaker needs to be able to take. Just ask them. It's kind of like saying, well, do you drive fast? Well, for some people, driving fast is 60 miles per hour. For some people, it's 150. That's not...
That's funny.
Yeah. Are you the 160 mile per hour kind of guy? Yeah. Very careful. We all went driving once, and we could see who liked to drive fast and who liked to just, relax.
Good with the little racing, though.
Yeah, she didn't spin that. She did not spin that car once. I spun out at the end of the straightaway on one of them. Like when it was still wet, I was like, whew. It was fun.
That was fun.
It was fun.
You hear a lot about, because I hear you talking about these points on speakers, and something that you always get a rebuttal from other manufacturers is this efficiency. They tell you, don't look at wattage, look at efficiency. Efficiency is the real key to speakers. What do you say about that?
That's wrong. The right thing is efficiency and maximum input voltage. I don't really like wattage because that's a little confusing, because it all depends on the impedance and stuff. It's really how loud does it play and how efficient is it. How efficient it is tells you how many watts you're going to need to get there. So this stuff gets confusing because it's like, well, I don't know. How do I figure this out? So the good news is I'm heading up a committee within CEDIA that's standardizing all this. So if I have my way in the next year or so, there'll be a set of documentation that does this. Check it out. this speaker has this efficiency in decibels, which is what happens when you put 2.8 volts into it. It will play up to 102 decibels. It won't tell you how many watts it takes. It goes, its reference is this, it'll play up to 102, which means that's the loudest you would want to go before, just random number. That's the loudest you would want to go before it starts to become a liability in terms of reliability. And then you go look at the amp and it goes, this amp plays up to 106 dB relative to 2.8 volts. You just match the two. So now you know you have a speaker that has a capacity of playing 102 dB, and you need an amplifier that can go up that high. That's all you need. You need one more piece of data. How loud does your client want it? There are clients for who playing 102 dB would be way louder than they would ever want. And there's people for who that's just getting exciting. Okay, but the math will be super simple. You look at the amp spec sheet, you look at the speaker spec sheet, you look at what your client wants, and you just connect the dots.
I was always taught to overgauge the amp on the speakers.
That's a good idea. You don't want the amplifier clipping before the speaker. So if a speaker can take 28 volts, you don't want the amp to clip at 25 volts, clipping being that it's starting to distort, because then really ugly stuff happens through the tweeters. You want to make sure the amp can clearly go over that. But if you have too much amplification for the speaker, you could also blow it up. So there's a range there. A few decibels one way or the other is just fine.
I was taught it was more so, it was the energy that would require to pull the woofer back, not so much push the woofer out. Was there anything to that?
No, that's wrong. Yeah. Pushing and pulling, it's all the same. So, but what matters is that you don't distort the amp, because once you do, once an amp goes into clipping, the energy in that clipped section is very high frequency energy, and while you're not necessarily hearing it, the tweeters are taking it as heat, and then they end up burning up. So you want to make sure you don't overdrive that. So, all right. Now, let's talk about the sound power thing a little more. I mentioned, it's important for the speakers to have good axial and off-axis response. I want to show you how important that is. You guys have seen this diagram before. You guys haven't. I'm going to show it again. So, let's say you're in a room and you're listening to the center speaker of the room. This is a view from the top. This is a view of Paul Muto's cranium. and kind of mine too. Yeah, that's pretty close. Yeah. So this is a room seen from the top, 7 speakers, so in a 7-channel. We're not seeing the top speakers if it's in an Atmos one, and we're listening to the center speaker. There's a wave of sound that leaves the center speaker and goes to Paul's head. Okay, that's what's called a direct sound in blue. But a speaker doesn't just beam sound straight in front of it. It also has some sound that goes off axis. In this case, here's the sound out at about 40 degrees. It's going to bounce off the wall. That's one reflection. So if I am the speaker over here, I'm going to send sound to Paul's head, and some sound's going to go over that way, maybe diffract off this cabinet, hit that wall, return back to him a little later. So that's a reflected sound. The reflected sound is later and a little quieter. But the reflected sound is not alone. There's a whole bunch of other reflected sounds. So if you look at all the boundaries, up to 3 or 4 reflections from the left and the right side, I'm not even including the ceiling and floor here, I'm just looking at the lateral ones. There's all these reflected sounds. So we'll just follow one of the paths. Let's follow this one. Bink. It goes up here. It goes there. It goes back over here. And then it reflects back to the listener after 5 bounces. So you could have one direct sound, one what's called first reflection, a second reflection when it goes right wall, left wall, and comes back to you. You're going to have multiple reflections. All of those reflections are quieter than the direct sound, and they arrive later. But I think you can see that when you sum total all the red arrows, there is a lot more energy coming back from the room than there is direct sound. So the reflections dominate. That's the fact. That's not myth, that's not legend, that's the fact. There's ways to measure that, but the interesting thing to know is the closer you get to the speaker, the reflections stay about the same. Whether you move here or there, the reflections are going to come from somewhere different, but the net total reflected energy is the same here as it is here. And it's also the same here. So imagine that right there is a speaker. If you get close enough to the speaker, the direct sound gets louder, and you get to a point where the direct sound and the reflected sound is equal. That's called critical distance in room acoustics or in electroacoustics. And where is that? I know you guys have heard me say this before. Do you guys know? In a typical listening room, typical place at home where somebody's listening, that's actually 2 meters, 6 feet from the speaker. So you're sitting on your couch, you're like 13 feet, 14 feet away. What you're mainly hearing, while there is a sound coming from the speaker, you're mainly hearing all the reflection energy. You get up, you walk up to the speaker, and when you're 6 feet from it, it's equal. So there's as many reflected sound vectors, the net energy coming into your eardrums is equal. But now you're just 6 feet from the speaker. If you go 3 feet, now you're dominated by the direct sound. That's how bad it is. In other words, when you're 12, 13 feet away from the speaker, what do you think is the ratio between reflected versus direct sound in a typical speaker? How much more? Way more. Want to hazard to guess?
75% more.
Depending on what you call 75%. Typically 3 to 4 times more reflected energy coming to you than direct sound. And in fact, it's so bad that in some cases in a room, I shouldn't use the word bad. It's so reflected that in a room, if you're sitting over here and there's a pair of speakers a bit far away from you and the room's pretty reflective, somebody can walk right in front of the left speaker and you won't hear any change in the sound. Is that nuts? Why? Because that one little thin vector from the speaker to you is like one small portion of what you're hearing. Somebody stands in front of it, you don't even hear a change. Why am I telling you this?
Because you can overtreat a room and destroy the room.
We'll get to that in a second. But why am I saying all this about the reflected energy? If the reflected energy dominates, if the majority of what's going into your ear canal is reflected sounds, you want to make sure that the reflected energy is good quality. So imagine you make a speaker that's got really good sound right in front of it, but it sounds like dog do in that direction, in that direction. What are you going to hear? Dog do. Good answer. And that is an issue that people don't pay enough attention to. What you want is a speaker that has good sound in this direction, and also in this direction, and also in that direction, so that not only does everybody hear the same quality of direct sound, but also that all the reflections that are dominating your energy in the room sound good. That is a speaker that sounds good. And guess what? That's what that is. That's a speaker that radiates directly in front of it very nicely, and as you move off axis, the sound barely changes. And that's why it sounds so good in this room that's big and reflective, has no treatments other than a stack sitting right behind you that are not doing anything to the room. That is really the key secret. I feel like I'm I'm doing an infomercial. That is the secret to good sound health. But if you call now, I'll send you some Ginzu knives that have lost their sharpness. This is what matters. Now, don't just believe me. The best experts in the world say this is true. And if you pick up books from most of the top acousticians in the world, you'll find that story put out. They're just not making speakers. I actually found a reference back to a book from 1952 by Harry Olson, old school acoustician, that claims that's how you should design a speaker. This is not new info. It's just taking a really long time for people to get on it. Or in the history of the world, you could go, what's 50 years? It's nothing. Because, it took us 2,000 years to realize that we actually lived on a ball rather than a flat surface.
And still debated.
And some people debate it, yeah.
You know that there's members of the Flat Earth Society all over the globe?
Yeah. Did you?
And I've seen like a thing that said that from them.
Yeah, you gotta love that, right?
So what's funny about the Flat Earth Society is, in a way, it's it's fun. It's like play. It's like, well, let's pretend. No, it's not. It's round. We've seen it. Any sailors? Anybody's been on a sailboat? Anybody? So have you gone far away enough that you don't see? It disappears, but you don't fall off the edge, right? You keep going and you don't fall out. I did a bunch of blue water sailing, and I'm always amazed that you could be there and you see nothing, and suddenly there's a container ship coming at you. And you know how far it is? When you're on a sailboat, you're looking at the horizon, that thing starts to pop up. It's only about 3 or 4 miles away because of the curvature of the earth. Before that, it's like hidden, and suddenly it's there. And if it's coming your way, you better start thinking about what you're going to do, or else you'll become a container. Yeah, you had a question.
So back to the reflection. So in the theater room, it doesn't matter if the speakers are actually at ear level, if what you're hearing is 75% reflection, right?
It does. So that's actually a great lead in. Yep. Why don't you go ahead and ask that question again so I can get a sip of coffee.
So in the theater,
Or a listening room.
Or in the listening room, do speakers actually have to be at ear level, since what we hear is 75% of reflection?
So that's a good question. Where do you put the speaker? So there's a contradiction to what I just said, which is like, well, there's all these reflections, but I can still hear the speakers there, right? When I play the pink noise on the left speaker, believe me, in this room there's a lot of reflections. You can still hear it's there. How do you hear that? If it's all dominated, are you lying? I could be lying. Well, there's this interesting signal processing going on in our brain that's known sometimes as the Haas effect or the precedence effect. Our brain, our ear and brain are like this three-dimensional radar, always listening for where the first arriving sound is. So when you're sitting there, the sound of that speaker is a first arriving one. But then there's a reflection from the screen that's just a little later, another one. And your ear brain is able to untangle, as long as the sounds are all the same pattern. So the direct one is like this, and the other one's like this, but a little delayed. The other one's coming from there. As long as they're all similar enough, you're working on patterns, and you're going, well, I just heard these 50 different sounds, but the first one came from over there. And that is how you can still tell that it's over here, even though it's 3 times quieter. Now, what's that about? Well, in our evolution as human beings, we learn pretty quickly to detect where the first arriving sound is and go, it's over there. It's a velociraptor. I better run. The people who were not born with that, and not everybody has directional hearing. There's folks who they can't quite tell where sounds are. Just unfortunately, their brain function didn't work that way. Or as we get older, we lose that. Little babies don't have that. You know, any of you guys have kids. You know that when the babies are small, they can hear the sound, but they can't tell where it is until their brain function starts to develop that, and they finally go, "Mommy."
There's a disorder that the surround. The minute you turn on the surround, people will lose the function of understanding what the words mean. So if we made it all silent in one speaker, they would understand. When you talk to someone, there's a listening disorder where people cannot understand multiple sounds coming from different directions. They lose the intelligence of understanding the words. It all sounds like mush, but if it comes out. So if you walk into a theater, and you'll get that from customers sometimes, they'll be like, I don't understand the words. I don't hear the words. Now, some people will tell them, oh, just put the words up. The reality, putting that words up isn't going to fix anything. It's something inside. They'll never understand the words. So you have to understand that as well, understand what your customer's doing.
Yeah, you can't have it coming from all these directions at the same time. That's what happens when they use the all-channel stereo mode, and it's all bouncing from everywhere. Anyway, so that's a long answer to your simple question. The fact is, you're still gonna point to the first arriving sound, and so in a theater by design, the side speakers, the surrounds, need to be 15 degrees up from your field of vision, from your ear height, not at listening height. So anybody who tells you, oh, you got to put these speakers at seated ear height, they don't understand the standard. The standard being the film mixing room. So when the director and the sound designer and the mixer and all the people involved in the sound sit at that mix room, they're listening to speakers that are in the middle of the screen in front of them, and the sides and backs are all up 15 degrees. So how do you figure out 15 degrees? You either do trigonometry and math, or you just count on the fact that it's about 20 to 24 inches above your seated ear height. So you typically sit at about 4 feet off the ground. The middle of the speaker should be between 5 and 6 feet up. Now, it gets further interesting than that. What a size okay, so now they're up here, and what if you have one of those speakers that's kind of beamy, where the sound goes straight out and not so well down? Now you have to tilt them down, right? Just remember to do that. Otherwise, you're going to be putting it up there, but you won't really hear it. You'll crank it up, and it's going to sound funky, so you got to be careful about that. One second. So what we've done in these speakers, every one of these Rixos speakers, it's made for home theater, the sound is inherently pointed down 15 degrees by design. It's designed that way. Now it's not super beamy, but it's designed so when you put it on the wall, it's aiming straight, it's going down 15 degrees. Now, the tolerance of it is you can, on this particular speaker, you can go up to plus 10 and minus 45. The actual sweep of sound is about like this. So it's not like you get up and it's all gone. It does have a range, but you can put these flat on the wall and not have to aim them down, which is one more little thing we did to make your life easier. Nice. And most people don't bother aiming them down, then you end up like some of the theaters I worked on this week where it's like, well, they're aiming over your head, and you're going to have to turn them up, you're not hearing them, and it gets to be difficult to tune the room. So these are designed that way. Michael?
Now the Rixos, the towers, so if you were going to surround the seating area with these towers, how would
the towels, you mean?
Yeah, the towels. How would you compensate for that?
That would be challenging. They're not really made for that. So if for some reason you had 5 towels, you said, I love these speakers, I'm going to put 5 of them. You would have the left and right over here. The center one's going to be in the middle of the screen. I don't know what you'll do. Well, maybe you use an acoustically transparent screen. That will work. For the surrounds, you would actually want to raise them up and tilt them down. You would need to do that. And you can turn them upside down if you want, putting the waveguide at the bottom. It's not really made for that. It's made to be a floor standing tower speaker. And we make speakers that are every bit as good as the towel as an install speaker that's made to go flat on the wall. It's just not as pretty, right? So this is a really, if you guys just remember one thing from all these like 3 hours of me yakking away, this is the one thing I really want you to get, because this applies to every speaker you're working with. This applies to a ceiling speaker. So these kinds of ceiling speakers, especially this type with a dual tweeter, is going to sound this way or right here, and you move over here and it's going to lose all its highs because the 2 tweeters have interference with them. And you got to know that. And so if you do a ceiling layout in like a dining area or a great room and you wanted to wash it with sound, and you don't place the right speakers in the right place, you have a hot spot right under the speaker, and you go over here and the sound is half gone. And that's not the way it should be done. It should be really even. Okay. Now, if you were lucky enough to work in the commercial business and you had audio engineering chops that allowed you to do this program called EASE, there's a standard in the commercial side where the speaker's polar patterns, how they spray out and bubble out the sound, is well understood. There's little pieces of software that go into the EASE program. You draw up your room, you put the speaker in there, and you can actually create a heat map at standard height, sitting height, of what the sound is. My little dream is in the world of CEDIA and residential, we can get to that point too, where we can just design these things on paper with all the right data, and from there install the thing in the residence, and it actually sounds good. So be on the lookout for that. It's called Performance Facts within CEDIA, and it's all about helping you standardize how you design the projects. Okay, so because this business of the reflected sounds being really important, we designed what's called a CSA waveguide. It stands for Conic Section Array. If you look carefully in there, you'll see that the little sections in there are little parts of cone. The small one at the top, then it lifts off to a wider cone and a wider cone and a wider cone, progressively transferring from one to the other. CSA, Conic Section Array. All right, that is what gives us the sound power we claim in Grimani system speakers. That's what is the real driving factor. So here's an example in our alpha speaker of the CSA waveguide, all the way at the top over here. It is our secret sauce. That's what makes these 2 little speakers sound so good in this big room. It makes that you can sit over there and still hear a soundstage, that you can sit in the middle and it sounds about the same. Maybe later when we have time, I'll have you guys just all move around and you'll go, wow, it barely changes. And it gives us a really wide and smooth horizontal dispersion for full sound power in the room. That's a close-up of the alpha's tweeter, and you can really see the cone sections. Little one here, medium one there, wider one there, and really a very wide radius one at the top. Now, when you look at that from the side, if you actually took a slice of the alpha speaker right down the middle, looked at it on the side, you'll actually see that the tweeter is mounted on the bottom, and it fires up through the waveguide, through the mouth of the waveguide, and disperses out in the room. It's kind of like an acoustic equivalent of one of those garden irrigation nozzles that's designed to spray all your whatever you want it to be, or flowers very evenly. So it provides a higher efficiency loading of the tweeter, so the tweeter is more sensitive, especially at its lower frequencies, and controls the distribution of the sound to where it is even in both directions. Now we can control how wide we want it. Doesn't mean the sound has to be a full 180 or 90 or 20 or 30, but what we design for is typically plus and minus 70 this way and plus and minus 30 this way. So we control that in the waveguide, and within that range the sound does not change. All right, so this is the intention. This is a view from the top to have wide horizontal spread at all frequencies, which means that all the seats get even sound, and the reflections and the direct sound are matched. You get good sound power. So that is the holy grail in speaker design, to have really even dispersion. Different people have tried it different ways over the years. This is how we practice it. Now, the way this gets measured in the lab when you're designing these things is you do what's known as a spinorama test on the speaker, which is you put it on in the room on a little rotating dolly. You put a test microphone, kind of similar to the one I have over here. You measure it on axis, and then you turn the speaker 10 degrees, you measure it again. You turn the speaker 10 degrees, you measure it again. And you do 70 measurements around the waist this way, or it's actually 35 in this direction and 35 in the other direction. You turn the speaker on its side and you remeasure. And so you actually have a set of measurements from top to bottom and left to right. And from that, you have data over what's the direct sound, what's called the listening window, which is an average across this direction, et cetera, et cetera. I'm going to talk about that. So once you're done measuring these 70 curves, you can represent them in what's called the spinorama display. And the standard in the industry at professional level is to show the axial response in black, and then in green what's called a listening window, which is an average of five points this way, minus 45, excuse me, yeah, minus 15, minus 30, plus 15, plus 30, and plus and minus 20 this way, or plus and minus 10 or 20. I think it's 10 now. And those 7 points are averaged together in what's called a listening window. And it's called a listening window because it's kind of like, if I'm a speaker and I'm looking at you guys, this is what I see. I see people at different height and different widths, and that's the listening window. And so you show that. And then you also show what's known as the reflection window, which is the energy going over to the walls. So that's the early reflection section. So that's what gets past the listening window. So 45 on up this direction, 45 on up in that direction, ceiling and floor. So that's what's going out to the room. And then finally you display what's called a sound power, which is an average of all 70 points with a slight weighting. And once you see these curves and you learn how to interpret them, you have a pretty good idea of how good a speaker is going to sound. So the idea is you would want the axial response and the listening window to be as close as possible to each other. And then you would want the sound power to be the same shape but turned down 4, 5, 6 dB from the axial response. The more directivity a speaker has, the more it's focusing towards you, the more the sound power will be dropped compared to the axial response. So that's less important than the fact that the sound power wants to be as smooth as possible. And this is the results of our alpha speaker. And you can see that the axial and listening window are very flat. This is plus and minus 1 dB, which is tiny. The sound power looks like the axial response just turned down 5 dB. There's a little bit of narrowing here to the tune of just 2 dB, and it comes back up and it's flat. And that's the sign of a very good speaker. This is the tau speaker. Also very good axial response, very good listening window, and a sound power that's a very good facsimile of the direct sound. These are the individual curves that make up these measurements. So this happens to be the Rixos S. And inside here is the 0 degree, 10 degree, 20, 30, 40, 50, 60, 70, 80 degree. I missed one. Oh yeah, it's right in there. So this should go all the way out to 90. But this shows that on axis, that kind of speaker has these responses. And as you go off axis all the way to 90, you still have good sound. It's attenuated. It's down about, what is this? This is 5 dB per division. So all the way over here, it's 10 dB down from the direct sound, but it's not like it drops off like a rock. Now, here's other speakers, other manufacturer speakers, okay, other people. I won't mention any brands, but here's a speaker. The response that's pretty typical, where you hear this is the 0, 0, 15, and 30 response of a speaker, and you'll see a big deviation over here. This over here is about 5 dB different. Here's somebody else's speaker. You look at the family of curves, and that looks really ugly. Not only is the axial response not very good, but the sound power, look at the sound power. This is the axial response here. That's the sound power. It goes drooping, goes back up, and it goes drooping. That's a speaker that's going to change a lot in its sound from room to room because the sound power is not very smooth. In a very anechoic space, very dead space, it will probably sound okay. In a very reverberant space, it's going to sound kind of like the red curve. It's going to sound dull. It's going to be missing some mid-range sound. So this is a speaker that in a room like this, the client would go, I can't understand the dialogue because it's missing the mid-range. There's somebody else's speaker, not a good family of curves. I'm just showing you the typical things that you'll see out there from a lot of manufacturers. This is yet somebody else's speaker. Again, just kind of to set a reference for what it looks like out there in the world. There's another way to represent this, which is called polar plots, which the commercial and pro audio guys are really used to looking at. That's just looking at the balloon of sound generated from the speaker. And this is our the beta speaker, I think. We no longer make this one, but it's very similar to the alpha. I'm going to ask you to look at the dark curve here. That's the horizontal response. This is at 1 kilohertz, 2 kilohertz, 4 kilohertz, and 8 kilohertz, and you can see that it barely changes all the way up. All right, it's very consistent, and that's the importance, is a consistency of response. All right, any questions on all this? All right, so one of the most important things in a speaker today is really no longer the business of distortion and other stuff that we used to worry about because it's all pretty easy to control. What's important what a speaker manufacturer should be obsessing about today is the frequency response on axis and off axis, and they should be telling you that. They should be showing you that. So I'm going to throw a challenge your way. Go to the speakers you normally sell from most of your vendors. And go look at their data sheets and find these, either the polar responses or any of the other data that shows you.
If they have data sheets.
If they have data sheets.
That's funny, because now you see people hiding it.
Yeah.
And then tell you 100 watts. You know what I'm saying?
Yep. So why are they doing that? Why are they doing that?
They want to hide the truth.
So I'm an optimist. I'm an optimist. So I'm going to say this. They are not giving you their data because you don't want it. And their marketing department goes, we only have so much room in our communication in our website. Forget the data. They don't want it. Don't clutter up the website with that. That's a positive spin on it. Now what's interesting is you look at manufacturers that are active on both the residential and the commercial side. And there's a bunch of people who do that. The same speaker on the commercial side, you'll get the full axial response, the full distortion, all the data I'm talking about over here. The same speaker on the residential side, they'll give you nothing other than 100 watts. Price, margin, weight in the shipping box. They have the data, and in fact, the data's not bad. If you looked at it, I'm not going to mention any names, but I've seen manufacturers where it's like, that looks gorgeous. Why don't you tell the guys at CEDIA about that? It's like, well, they don't ask for it. They don't know what to do with it. If we reveal it, then they're going to start to ask questions about, well, what does this mean? I don't get this. What is this? So that's called a lower common denominator. It's like trying to bat for, lowering the bar. I don't like that. It doesn't help.
Even wattage is a number that does
Yeah.
have no real relevance.
Recommended amplifier, 25 to 200 watts. What does that mean? When they actually know at what voltage that speaker is going to start to poop out. So I'm trying to change that. You're going to see, again, like I said, the CEDIA performance facts are going to give you that data. How loud does this thing play? What's its actual response? What's its polar plot? What's called the heat maps to show where can you put your listeners and still produce good sound. That's all available.
Does it make designing the acoustics for the room even more challenging because you do have this open, because it kind of radiates for the whole room?
Less. What makes designing the acoustics of a room challenging is not knowing what the response of the speaker is. Then you're just kind of trying to apply a generic for everybody. It's like, no, you need to know what the radiation pattern is, how wide it is, and design accordingly. And when we do our design work outside of Grimani Systems, when we're designing theaters, half the time I have no idea what the speaker's off-axis response is, and you're just guessing. I want to change that. Now, if you have a speaker with a really smooth off-axis response, all the way from the lows to the mids to the highs, you don't have to obsess as much. I know that sounds kind of weird. Check it out. All speakers are going to have wide dispersion over some range of their frequency. So a typical speaker at 1 kilohertz is going to have a pretty wide dispersion, as long as it's not an array of woofers this way. And then the dispersion is going to start to go down and up and down and up and down. And that's a difficult speaker to design for, because at some frequencies you want to attenuate the sound and other ones you don't. If you put everything across broadband, you're not consistent. It's a lot easier to design a good sounding room for a speaker that has an even off-axis response. So, okay. The next module of data I wanted to, how are you guys doing? What time is it? You're still breathing? You need a coffee? You're good?
We're good. We're good.
Okay.
You guys need coffees? Anybody coffees? Everybody good?
Snow.
Okay. So next thing I want to talk about is the fact that our products are all amplified. All of our speakers come with an amp. Sometimes the amp's inside the speaker, sometimes it's outboard, doesn't really matter. And all of the amps have digital signal processing control built into them. Why do we do this? So we're doing this because it's the right thing to do. There's a bunch of people in the professional audio and recording studio business that already do this and have been doing it for a while. Somehow that concept is very slow to enter the mindset of the residential space. And some of it is just resistance. It's just like, yeah, well, we haven't been doing it that way. Well, why not? Well, we just don't do it that way. It's kind of the same way as, you know, you go to Italy and most people don't know how to cook Thai food. But you go to Thailand and everybody there knows how to cook Thai food. You prefer Thai food better or Italian food? I don't really know, but it's a cultural thing. You know, and you grow up learning how to cook pasta and not how to cook chicken satay. That is what it is. This is all making me really hungry. The culture right now on the residential space is for passive speakers, wood box or plastic box, amplifier drives them, there's a passive crossover. That's just what we've always done, young man. And I think 12 just because it's been done that way doesn't mean it's the right way to do it. Maybe it is, but sometimes it's better to do other things. So check it out. I'm going to talk to you about what we do, and then I'm going to say, you know, actually, I'm going to start, why do we do it? First of all, it is more efficient. You can make a speaker play a lot louder and a lot cleaner with a lot more control if you have separate amps for the tweeter, mid-range, and woofer. If you actually address them all digitally, if you do the crossover and the room EQ all digitally, correctly done, you get what you just heard here, which is two little things that are cranking in the room way more than you thought they could. So that's the end game, is we can make a speaker that's way more efficient. And if it was a car, we can make a small car that goes a lot faster than a car with a giant engine, because it's just more efficient. So how do we get there? This is an example of the alpha speakers. So the whole speaker is actually shown in this red outline. There's its physical implementation, but inside the speaker, there's a digital signal processing board. It's actually a card that's about this big at the input of the speaker. And then the output of that goes to 3 different power amps, and I'm going to talk about what happens on all that. So first of all, in its highest end implementation, if you had one of the surround decoders that can spit out digital audio, preferably over IP, such as the Storm Audio and the Trinov decoders, you would take the output, the multi-channel output of that through one Cat6 cable, go to a network switch that's addressed for AES67, and that would go directly into the speaker as one cable, click. You program the speaker to know that it is the left speaker or the center speaker or the surround speaker. That's all done in the Dante controller or whatever the form of AES67 you're using. Then so the signal comes in, AES67. The alpha happens to also be able to take analog in. You can choose one or the other. Then there is a room correction EQ circuit. There's a time alignment circuit. There's a 3-way crossover. There's individual delays for the different drivers. There's a protection circuit so you don't blow up the speaker when you put 100 volts into it. And it's all IP addressable. This is what an alpha speaker is, very modern. It's essentially a computing device that happens to put out sound. Okay? It is not a computer. It's not a general purpose computer. It's a dedicated computing device. It's not running an operating system that crashes all the time, thank goodness, but it's a dedicated processor.
You just fixed half of the grounding situations that people deal with. Right there.
Three quarters.
Yeah, we just lost a huge amount of tech calls. We're figuring out.
You know, so you guys probably all heard that. His mic's on, right? So one of the biggest issues we all deal with is you just build up this big, beautiful rack of gear. It's, you know, it stands taller than me. You got all these different things. You bring it to the site. It's all clean. You listen, you measure, there's no hum. And then suddenly, during the construction process, there's hum. We've all seen this?
No, sound familiar, guys?
Of course not.
We're living it right now.
Never heard that. It's always perfect.
There is a way to make it always perfect, to where that doesn't happen.
By a Grimani system?
Well, ours is one way to get there, but also other practices in which you say there are no ground references that are going to cause ground loops. So the most common way for that hum to happen, and I'm sure you guys deal with all, the most common way is the cable company finally comes in and plugs in the cable into the cable box, and that ground is not referenced to the power ground. You got a hum loop. How do you fix that? The right way to fix it is you tell the cable company, you got to put your ground at the same voltage, at the same site as the electrical ground, please. You got to follow the law and the rules.
What?
And they'll, we plugged it in. I kid you not, years ago, I did see a ground wire connected to a PVC pipe. That's pretty crazy.
That's pretty special.
That's
That was in Cali?
It was not.
Oh,
It was not. Yeah. So you see all these funny things. That's a common one, or satellite dish that has a different ground. How do you fix that? Well, ultimately, little secret over here is if you just put get an optical HDMI cable, one that's going through fiber as a converter, made to run, hundreds of feet. You just go between your cable box and your surround decoder. Now you don't have a hum loop anymore because there's no ground shield around the HDMI. That's a really expensive way to fix a cheap problem. But that fixes it. But no, hum problems happen all over the place. There's all kinds of different reasons why things could go wrong. I often spend 3 hours chasing down hum loops. But if everything is connected in essentially for the signal path a floating ground, and the only ground is the chassis of the speaker that's making a safe device, you just got yourself out of a lot of service calls. The hum loops I hate the most are the ones where you've left the site, you've been gone for a month, and then suddenly something else happens on the construction site on the electrical, and there's a hum loop, and you're pulling your hair out. It's like, what could have happened? What is it that happened in the lighting network or the something else that brought that in? And you're pulling your hair out. And sometimes there is no solution other than putting everything through transformers. You have to put isolation transformers on everything to get rid of it. That is all a pain in the you-know-where. So the idea here is to simplify the connection, break all the grounds. Of course, don't use a shielded Cat5 or Cat6. Just use a regular Cat6 cable. You're done. So inside the speaker, what happens is all of this processing happens in the digital domain. In the case of our speaker, it's 40-point floating bit processing, so there's no noise accumulation or anything. And then each one of those signals hits an amplifier for the high frequency, the mid frequency, and the low frequency. That's how it is in the alpha speaker. Now, if we take a slightly closer look at this, doing the crossover and EQ and processing in the digital domain is more efficient. Efficient being that if you do it in the passive domain, the only way you're filtering out the signals that the tweeters are not supposed to get is that you're throwing away that power. So a typical crossover, typical passive circuit in a typical speaker loses about half the power, sometimes more if the manufacturer is trying to do things really, really smooth response. So 100 watts becomes kind of like 50 watts worth of available power. I'm dumbing this down, but it's just less efficient. And when you're used to seeing a speaker this big as a passive crossover, you're just used to how loud they play from that experience. But if you stop doing that, and like we have here, there's an amplifier driving the tweeter directly, an amplifier driving the woofer directly, it's like, man, that's a lot louder than I'm used to hearing. Now there's more, but wait, there's more. So it's also more precise. We can do things in the crossover of these things that make them way, way, way cleaner, way better, way more precise than you can out of passive components, and it's a lot more flexible. You can do things that out of either analog circuitry or passive circuitry you just can't do. It all leads to better sound quality, and in addition to just making a better speaker, we also, in our speakers, we have leftover signal processing so we can do room response correction. Okay, so the thing we've been talking about a little bit earlier, which is the room correction done by just pushing a button that's done in the receiver or somewhere else, we do that in the speaker. Okay, and we do that correctly. So this room response EQ is about custom tailoring the speaker to the room, or in some cases the listener. Most people agree to what is good sound. Some people like a little more high frequency, more bass. Noel loves a lot of bass, and that's just what he's used to. And so when you design a room for Noel, you design a thing, you tune it, and you give him about 4 or 5 dB more bass than what reference says, because that's just how he likes it. If you don't have that control available, you can't make him happy. But we have that control available. So this is what the signal processing of what goes on inside, what is this? This is a Rixos S, so about the same thing as we have here. This is the actual screen you would see if you logged onto my laptop right now. I'll show you that. Where it shows the inputs, it shows you the voltage at the inputs, it shows you the room correction EQ. This is the left speaker, that's the right speaker. Inside this block and that block are the actual crossover in EQ to make the speaker be a right speaker. That's kind of factory locked. And then you have the output voltages, so you can actually monitor what's the tweeter getting, what's the woofer getting. This is inside. It's so funny. I'm used to doing this with a regular projection screen. I point at this and you can barely see it. But inside this block here is the crossover. This is the woofer response. This is actually what the woofer is being given so that it sounds good. And there's a little trick over here that the filter to the tweeter is very steep. Starting at about 1 kilohertz, we fall off like a rock. So the woofer is not carrying any high frequency. And this is the tweeter response. And like right down here, that's blocked off. So the tweeter below 1 kilohertz is getting absolutely nothing because the slope is really, really steep. It's 48 dB per octave. That's one way that we can make this play louder than you're used to, because a typical passive crossover would be typically second order, first order for some second order, which means that below the crossover, there's still a lot of energy trailing down, which means that when you crank it up, the tweeter is working hard at frequencies it doesn't want to be working at, which results in two things. It don't sound so good, and it's going to blow up. So we do these things of having super, super steep crossovers. We take the crossover a little lower than most people go, but we do it super steep because it's in the digital domain and it's easy to do. And that's one of the ways that we get better sound and something that plays louder. So some people call that an unfair advantage. Fine. We're just using better tools. So another interesting thing.
Are you actually using less wattage? Even though, because when you look at it, I guess we are going through this use less electricity thing right now.
Yeah.
And it in a way almost feels like we're contradictory. We're using more electricity. You hear all this wattage, and the system is sounding like thousands and thousands of watts, but in reality, that is just like extra horsepower, but we're probably not even using half of it.
What I like about Michael Restrepo is he always asks amazingly thought-provoking and cool questions that I would not normally think of putting in a presentation like this because we'll never get done. But since he asked, I'm going to go there.
Yes. Everybody said to me, why are you doing this for 4 hours?
Because Mike's in the room. So,
4 hours?
So Michael, you know.
I thought it was 8.
To our television audience, I will say Michael Restrepo asked a really good question. So actually, your question has about 5 layers of the onion in it. So first off, I'm going to say these amps are very efficient, which means that in order to get 600 watts out of the amp, you're using much less power than a traditional Class AB amplifier. And that's the easiest way to feel that is in heat. You put your hand on the amplifier. As it's sitting there at idle, it's barely warm. And when you crank it up, it is not nearly as hot as a traditional Class AB amp. Heat is not useful for sound output. If it's cold, maybe you can use that heat to heat up your house, but it's inefficient. So number one, the amps are more efficient. For every watt coming out of the wall, we put a lot more in the speaker than a traditional amplifier. These are what's called switching supply Class D plus amplifiers, very well designed by some really, really top engineers, and they sound amazing, and they hardly use any power compared to regular speakers. One. Two, because the speakers are way more efficient, we need less power to produce sound pressure. And so in a second here, I'm actually going to switch screens to a real live thing. I'm going to play one of those tracks. I'm going to crank it up, and you're actually going to see how many volts and watts are going into the woofer and tweeter. And you'll see that even at loud levels, the woofer is getting 4 or 5 watts, and the tweeter is getting half a watt. That's it.
You put all your stuff in everybody's house will cure climate change?
Yes. And you'll have really cold houses because there you go. That's a great campaign.
Because you don't even have to worry. Because a lot of times everybody's searching. I guess at the highest levels, you're searching for that next 20 amp breaker. Like, how are we going to get that into this room?
No.
But even though, if you were to count it, conventionally, if you were to count it, you'd be overgauging. But the reality is, you're never using that much watt.
Never using that much watt.
So you could put it on one breaker, even though you are thousands over. You're never going to.
I'm always careful about claiming this, because you can get into trouble. But you can run a Cinema 1, which is like 40,000 watts of available power. When you add up all the watts, all the woofers, all the tweeters, all that stuff. You can run it off 2 20 amp breakers. And math says you're completely lying. Mm-hmm. Right? You know what 20 amp breakers in terms of maximum wattage is supposed to do, right? 2,000 watts.
Okay.
More or less, 2,400. Right? And I'm claiming you can actually run something like 30 or 40,000 watts on what's available for 5,000? Yes. Why? Because these things are super efficient. The amps are never using full power all the time, everywhere at the same time. And because these are high efficiency regenerative amps, they kind of work like a hybrid car. The energy that's not being used is getting fed back into the power supply and being reused later. So it is kind of nuts, but if you guys ever do an install like this and you plug it all into the breaker and you do one of those amp meters on it to see what it is, you can be listening to a movie at full tilt boogie. It's going boom, crap, blah, 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 and you see like 500 or 600 watts coming through the amp meter.
Now you would see some providers doing the 220 trick and then creating efficiency that way. How are you doing it?
So these amplifiers are actually auto switching. You can run them anywhere between about 90 volts and 250 volts as you want. And the power supply just adapts to that. It is true that running at a higher voltage is more efficient, not because of the amp, but because the wires along from the service to here, when they're running at twice the voltage, are using half the amperage. And that means less voltage drop across the wire, less losses. And so in countries, in the rest of the world in the US, except for Japan, a few other countries that run on 220 or 240, you'll notice the wires are all really thin, and you'll notice there's less of this dimming of lights when you turn your toaster on, because you get a lot more current. Let me show you this one last thing, then I'll switch over to the laptop. So there are essentially, if you look at any one of our Rixos S or any Rixos M, there's three EQ circuits working. There's the low frequency, the woofer drive, which is a factory set one. That's what it takes to make that speaker sound good. There's the tweeter drive. That's what it takes to make that speaker sound good. And then there's the room correction EQ, which is the one you guys are going to interact with to make the speaker work in the room. Okay, and that's the one that's available to tune the room. I also want to point out for those of you who want to see it that a traditional tweeter would have a response curve that's like this, that falls off at high frequency, but the energy would be about the same. You'll notice that in our speakers, in this particular speaker, the tweeter is actually turned down about 12 dB at the lower frequencies. You see that shape there that you can see here? What's that about? It's not that we're boosting the high frequency, we actually are reducing the low frequency part of the tweeter, because it's mounted in a waveguide, it's more efficient at its lower frequencies. If we didn't do that, it would have a giant hump in this region. It would actually sound way too mid-rangey. Is that a good or a bad thing?
Bad.
It's a bad thing?
In the tweeter?
Yeah.
Good because they don't like to use the whole power, so it don't blow up, right?
That's right. So the really nice thing about this is that the waveguide is giving more efficiency to the tweeter in its lowest frequencies where it's more prone to blow up. So we can turn the tweeter way down, not across the board, but in the 1 to 3 kilohertz region where it's more sensitive to blowing up and having distortion. And it's idling, which is another way that we make these little bitty guys play so loud. It's the waveguide. It's increasing the efficiency of the tweeter, which makes it work less loud and be able to play louder. Okay? Sorry? Well, the hum is still always going to be a problem. Less of it. So let me switch over and show you live. So right now, this here is a live version of what I had in the presentation. This is the application made for these amplifiers. It's called Harmonia. It's the control monitoring, system programming, system configuration, and EQ tool that comes with the system. Okay, and the first time you open Harmonia, you're going to sit there going, "What do I do?" And then we teach you. You push this button, and you go, "Oh wow, there it is." It's actually, there's a little bit of a learning curve just in the beginning, but once you know the 2 or 3 buttons it takes to get to this, there you are. So first of all, this is a map of the amplifier. I guess this is the left channel, if I'm following correctly, of this amplifier inside here. It's showing that there's 4 inputs. We're only using 1, but there's 4 available inputs, and those inputs go to the left speaker, tweeter, and woofer, and the subwoofer. So in that system, I would call this a 3-way speaker, where there's a subwoofer, a woofer, and a tweeter, and that's all driven from 1 amplifier. Now, inside here,
Wait, if you could move back. So you didn't have to get another amp for the sub?
No.
Because you're just counting channels.
This is a 4-channel amplifier. Channel 1, 2, and 4. So we're using 3 channels out of that.
Can I use the bigger CRS ones and just run more channels off of it?
Yeah. Yeah, you could. Yeah, absolutely. You can use an 8-channel amp and drive all this together. What we have right now, think of this as in that rack, in that 1 U high of the rack, there's 8 channels of amplification available. We're using 1, 2, 3, 4, 5, 6. There's still 2 channels available to do something else if you wanted to.
When we start bidding it out, are there, on how you order, are there times where one is kind of cheaper than the other?
Yep.
And do we work on?
Correct. So it's so cool working with you because you're always asking these questions thinking ahead. This would be part of our conversation later. So we go, here's the price of a Rixos SND, here's the price of a woofer, here's the price of this. You go, I got a client. Okay, and I'm going to go, Michael, we can do 2 things. You can just order the standard thing and not ask me any questions, or we can take 5-10 minutes to talk so I can see if there's a more efficient way to do this. And we'll go, I noticed that you could, if you mixed and matched these Lego blocks in this other way, we could use up less rack space, have less amps, do more amps, whatever you need. There's a certain amount of flexibility in this. You can always just build it, brute force, and go, you just use a straight thing. But there's always an efficiency in looking at it a little more carefully. So on a system like this, I will tell you there's 2 available channels to do whatever you want with, including powering the speakers in the ceiling of the kitchen, if you wanted to. Right? They happen to be sitting there doing nothing. Okay. So that's the high frequency. That's the low frequency. This one is blank. That's right. This one is muted, not doing anything, and that's the low frequency of the subwoofer. This over here inside this block. This is actually the input-output matrix that shows that input 1 is fed to all the outputs, just the way I've configured it. So I have 1 signal that's hitting the tweeter, the mid-range, and the woofer. And then this is the room EQ. This is what it took to make this room sound good, right? Not a whole bunch. Plus and minus 3 dB, like bink, bink, and then a little bit of this. That made the room not just sound good, but measure well.
That's not even a lot. I've seen other speakers
all
over the place.
Yeah, I understood. I work with those all the time. And then this is the factory set response of the woofer and the tweeter. Like this is the, you don't touch this. This is like the equivalent, the digital equivalent of the passive crossover inside the speaker. So let's poke at this a little bit. And I am going to play a little bit of music and just kind of show you what that is all. That's what's going on inside here. I'll go back to what track. What should I play? So I'm going to play something from within the laptop, so I'm not relying on an external connection. That is. So I'm going to play Tin Pan Alley, whatever. So, and I'm going to turn that.
And it didn't matter, like whatever you could think of, it was there. It was crazy. Yeah, it was really cool. It was really, and you got to hear it. I like that. Everything from like hip hop to classical, like it was all there. It was really good. It sounded amazing. If you ever get a chance to hear the Alphas are totally some of the most intense speakers I've ever heard.
Yeah, Tony's going to send them to my house.
I'm serious.
Oh.
Now I gotta get rid of my induction. I don't know. Get these for the house. It's the next toy.
Maybe my phone latched onto that. Hold on one second now. Turn the Bluetooth off over here. Remember, I'm feeding this through Bluetooth through the speaker. Give me a second. Ah, the wonders of Bluetooth, huh? Turn all this off so there's no competition. Well, yeah, sometimes that works more better, huh? Okay, what's going on? What's happening here? No, it's saying it's not connected. Oh, I know what I'm going to do. This device and their Bluetooth device still discoverable.
Yeah, we gotta hook him up. What's up? Come on, and get him a shirt too. Tony got a strap on the G-string.
Yeah. Ever wants a green one, let me know.
It's a G-thong. Right? Like, I didn't wear that when you hit. You didn't go out, right? Kyle bought that in.
Okay, come on, we can do this.
They were strike on cheap, bro.
Cannot be a thing.
Green in the back.
Stop.
You go up there and jungle all the time. Sometime.
You want me to start rapping, guys?
Yeah.
On this mic, and I drive a bike.
You ride the mic.
Okay, coming up here.
Bing bong.
I didn't understand you. I didn't understand. Rice beans,
I
cheese,
love that
Christ,
guy,
and
man.
fire.
I love it. Joe Stelman knows the dude. I've been telling Stelman, you gotta hook me up with this guy. I want to bring out
knows
this
him?
thing. Yeah, he knows the guy. I'm trying to go out there and meet with him. I want to be with him.
Byron?
No, the dude from
From that
YouTube,
video?
Bing Bong. Like, there's a guy on Staten Island. I'm trying to meet up with him.
Oh my god.
I got to meet that the sheetrock guy that they became a. I met him. I met him. I found him online.
I just have to start following you everywhere. Don't tell him that. He likes that. He knows he has fans. He knows he has fans. Please.
You know, remember that day we were eating dinner and so
Wow. Okay. We may have to forget this for now.
Just reboot it.
I just did.
Did you try turning it off?
Oh, Dan. Tony is deep in lamp mode, bro. Whoa. I was waiting for you to put your hands in your pants or something. Like, oh, man.
Tony's like, welcome to my house. My house.
Oh, you it's bro. That's so nice.
It's better on live mode, though. It's better in live.
Okay, we're just going to keep going. I'll wait for this Bluetooth to wake up and do its thing.
Of course.
Maybe I'll reboot the actual phone. Reboot. It's the router.
I blame it on Tony breaks
It's usually Jamie's
everything.
fault, though.
Tony, why you break
Jamie,
it, bro?
why'd you?
I'm really good at that.
Seriously? What'd I do? What did you do wrong?
Okay, so let's switch gears. So this is
I connected to it.
le-
I want to see if I could.
you connected to it? Okay, so we'll use your music. What do you got?
What do you want to hear?
I don't know. What do you got?
Want to hear some Michael Franks?
Okay, let's do Michael Franks. Oh my God.
No, that was you, bro. That was you too.
Dave knows every freaking track. This is the craziest thing. He'll know you.
Ain't nothing but against the party.
Yeah, buddy.
Oh shit. You done fucked up now. You done put two of America's most wanted in the same motherfucking place at the same motherfucking time.
So what I want you to see, Snoop's playing a little loud, not too loud. This is actually the volt, amps, watt, and power both, or voltage both long-term and peak of this woofer. Okay, just this woofer. This woofer can take 150 watts. The amplifier that's over here, it can feed at 150 watts. But at this thing, I want you to take a look at the voltage over here, both long-term and peak, and at the power that's calculated there. So go ahead and turn it back on. Can you go back to the other track?
Body. Ain't nothing but against the party. Oh shit. You done fucked that now. You done put two of America's most
This is the subwoofer now. So before we go back, I don't know if you saw it, but that was pretty loud. To me, it sounded pretty loud. The woofer on the left speaker was getting an average of 3 to 4 watts. It can take 150. The tweeter wasn't even registering. Like you go there and it just says 0 because it's so low they can't even tell us. The voltage that we could see on the woofer, average voltage was around 9 or 10 volts, which 28 volts is 100 watts. Okay, so 10 volts is something like 20 watts of peak. It can take 150 watts. So at that level, we're still only about at a quarter of what this thing can safely do. Okay.
I love when you say these numbers because we're talking about like amazing speakers. Now you start seeing kind of the smoke and mirrors that everybody deals with when you see like another brand speaker. They'll be like, oh, you know, like everything's 150, 300 watts or whatever, and it's just such BS because the reality that number has no bearing to anything at all.
So it's interesting that you say that. Ever since I started thinking of engineering, I've always been confused by watts. Like, what is, like a watt is a unit, but how does it apply? We've agreed within the CEDIA committee, we're not talking about watts anymore. We're talking about volts, but we're mainly talking about decibels, loudness, the equivalent. What you care about is how loud does it play. If you're building cars, you'd care about how fast it goes or what the 0 to 60 is. That's what we're talking about. So at these sound pressure levels, which we should measure it. Let's find out how loud that was. At these sound pressure levels, that particular speaker the woofer is only taking a maximum of about 10 volts when it can really take about 35 volts. Okay, so you're golden. It's not going to blow up. You're far away from that.
And teeny tiny. We're not talking about like a 20-inch woofer. No, nothing. Even the sub is not even. Driver. Nothing is really moving.
So let's go back and play that. And now I've switched to looking at the. This is channel 4 of the amplifier. That's a subwoofer. So the woofer, as you can see, the subwoofer is averaging about 20 watts. That's the thermal equivalent. If you said, how hot is it getting? It's getting the equivalent of 20 watts, 20, 30 watts. The voltage is going up to midterm peaks of about 20 to 22 volts, which is like 80 watts. And the peaks, I don't know if you saw them, they're jumping up here around 50 or 60, which is 500 or 600 watts, but they're short peaks. They're like little bursts. We need the amplifier to be able to feed those. And the really cool thing about this amplifier is, again, it's a 600 watt brick. When the subwoofer needs the 600 watts, it's there going, here you can have it. But between the kick drum hits, it's like, oh, okay, the tweeter needs a little energy, the woofer needs a little, so it can share all that. You will not get this out of a regular, a normal 150 watts a channel amplifier, which would make up 600 watts, wouldn't do this because the subwoofer would be running out of steam when it needs the power. So because we're doing this power share thing, which is like, you know, you're just dishing it out to who needs it when it needs it, you can get this out of these small things. This is just called modern thinking efficiency. So the old school people would just go big brick, monoblock amps, every single one of them just does what they do without any ability to share with the neighbor. It just takes up more size, more rack space, more power out of the wall, costs more money, more prone to failure, because it's anything that gets hot is prone to failure. You guys know this in electronics, right? Yep. If things are running at 80 or 90 degrees, they're just going to fail. This thing is like barely warm.
I'm thinking in my mind integration of next generation, like, you know, we have a snowstorm coming in. There's something coming in. We're converting to power. I start turning off speakers. Yeah. You know, I already see. I have no landline, but I have power. I need to generate so much time. I have a storm coming in. Let's turn off this. Let's save power other places. So the more information or feedback, the more I can make the living space even more dynamic and more efficient.
Yep. And yeah, you can automate all that. So now let's play that again, and we're gonna switch to looking at what the microphone is thinking is going on here. And I'm gonna put two screens up at the same time. Same track. Just keep doing this. Yo, yo. And I'm going to show you both.
At one point, we got you got to put the two speakers into each other. You got to show them that.
Yeah, that was amazing.
That was amazing when they
was
did
very
that.
cool.
Uh-oh, Craigslist? Every Craigslist.
Give me.
Ain't nothing but against the party. Oh shit. You done fucked that man. You done put two of America's most wanted in the same motherfucking place at the same motherfucking time.
Okay, crank it up.
Bring out the champagne glasses and the motherfucking condoms. They have one of us, alright? And just let it get still. Picture perfect. I paint a perfect picture upon the hooches with precision. My intentions to get with you with that double OP. Double my fucking homie. You cold ass nigga on the mall. Show up. I keep my hand on.
So in the far field, that's 100 decibels, not peaks, but sort of short. The actual peaks are probably about 10 dB. So we're peaking at 110 with averages of 100. Okay, that's about as loud as you want to go. When people get crazy, they like to go to 120 dB peaks, but this is pretty loud. So here we are playing an average of 100 dB with peaks at 110. The woofers averaging about 30 or 40. The subwoofers averaging 30 or 40 watts long term with peaks at 600 watts. The mid-range is doing whatever it was, 2 or 3 watts with peaks at probably about 20 or 30, and the tweeter's doing nothing. So that's kind of the, what do I call this? Those are the numbers, like the facts about what these things do internally. What's really cool about this ecosystem is because it's all visible through IP, through, I can just dive in and look at what the amplifiers are doing, I can give you all this data. I could also, in the old world, by having voltmeters and oscilloscopes and peak reading meters plugged into the outputs of each amplifier, tell you the same thing. It just would mean I'd have a table full of all these different displays and stuff that you can't really port around. So what I love is when I go to clients' places and install all this thing, at the end, I like sit there with earplugs on and I crank it to, not just 11, but actually 12, and I look at the voltages and make sure everything is within safe range. And if anything's outside of safe range, then we got to go figure out, okay, if this person's going to play loud, we're going to have to do something different. I don't want you guys to have to come back and do service calls because somebody turned it up to 12. When on Saturday night they had one too many scotches and they're having a good time and they're like dancing. So I'm here to talk about good quality sound. I'm also here to talk about the fun of having a good sound system and how important it is to treat our clients well. The last thing you want, if you want referrals, is a client to have his and her friends over, having a little something to drink and dancing away, snooping away, and then suddenly everything goes dead. Really bad. Really bad, because you just blew up the amplifier, blew up the speakers, really bad. And that's, and then you get the call.
Or worse, you never get another call.
Well, you'll get, no, what'll happen is,
That's worst case scenario.
You'll get the call that, you'll get that call that night, it'll sound a little incoherent, like, hey, it's not working! And then you'll never get another call after that. So we worry about this at an engineering level to make sure you don't have to. I guess is sort of like the part of our message is like we've obsessed about this stuff. We've tested this. We've battle scarred through this to make sure it works. And in the end, it works. And the numbers are here. Any of you guys that are selling this thing, you get Armenia. You can poke. I'm not doing anything special. What am I doing right here? For the sake of ease, I have a Cat 5 cable. Cat 5e, woo, good quality, plugged into the switch that drives all this. Normally this would all be on a rack It's connected to the main residence switch. It'll be on Wi-Fi. You don't even need to hook up. But you can get all of this data instantly once you're there or when you're in your office. So check this out. We're about to go talk about that in a second. Is all of this is in a rack at your client's place. And you have a VPN tunnel into the client's place. You can log into this at any given time from your office. You can go and look at what's going on. Let's say the client's saying, you know, I'm having a party, want to make sure it's all working. During the party, you can actually log in. You won't be able to hear their music, but you can actually see the amplifiers bouncing up and down. You can go, all right, well, they're using about 100 watts out of 1,000 watts of the thing can take. We're good. So that's a cool part of it. All right. Now, before I get off this whole thing, I need to find, I wanted to show you how we measure this really quickly. But I'm off the Bluetooth link for some reason. You remember how I was playing, let me show you this over here. So you remember how I was playing pink noise before? That thing that went shh, and then I played the pink PN, the thing that goes I played that on here before on the left speaker. And I had one of your guys sit here with this microphone and spin it gently for me. And the result I got is in the red curve. Let me actually... Are you putting that on? Okay, let's do that.
Pink, white, square?
Pink. Pink on the, if you can, on the left channel. Is that? But it's fine. That's good. Let me switch back over. Okay. All right, so what you're going to do is you're going to play pink noise in both channels. I'll just mute the one I don't want to hear. So this is the piece of measurement software we use. And this software actually allows us to we can put a whole package together. Hold on one second. This is here. Give me a second, okay. All right, go ahead and play it.
Yeah, do that. In a cool little box and everything.
Actually, funny that you mentioned that. I was thinking about that.
You should.
Just show it.
With the little box, you should say.
You guys don't want to take the time to go.
Yeah. Okay. So just, if you can you be quiet for 2 seconds?
If you could.
All right. So this is the left speaker right now. All right, so that's the response of the left speaker after I've equalized it. I'm going to turn off the EQ bands I put on there, and you'll see what it was before. Can you guys hear how that changed a little bit? It turns out this room is pretty neutral, very slightly different. Like you, I forget, somebody said, well, that's not even that much EQ. That was a response before, right? So what you do is you look at what's coming up. So I'm talking over the mic, but let's pretend that that hump was actually what was in the room. You see that and you go, okay, well, I got to correct that. And you go grab a band of EQ like this one, and you can just slide it up and down. You can cut out frequencies. And you can hear that changing, right? So you can totally change the sound of the speaker, but the idea is to not just change it randomly to where you think it's right, but to actually measure and see, look, I'm trying to get to this relatively smooth curve. So we go over here. This is what we're measuring. I like doing this with 2 screens. I actually have a little portable screen I bring with me, a little small thing that plugs into the HDMI. So I put the analyzer on one screen and then the EQ correction on the other screen. It just makes life a little easier.
And that's nice because all the amps are IP, so it's not like some of the other guys that have like USB and all this craziness and all.
Not the new USB, the old USB.
Yeah.
PlayStation 3
Okay, you see the response there? I turned that back down and I just put a dip there and you can see it in the response right here. That's the result of that, right? And so okay, so if you want to kill it. So that's the process. So that's the process. So what's the difference between this and auto EQ? First of all, once you connect everything, you want to verify it's working, which auto EQ can't do. Then the process of measuring, you see the curve. And then you go, okay, well, there's a bump over here, there's a dip over here. You go grab the 3 bands and you just adjust it like a little video game until you get the target. And once everything is done, it's about 5 to 10 minutes per speaker once everything is set up and working. So an auto EQ with Dirac of doing a 13.4.4 system, between the time where you hit go and you're done is about a half an hour, in all the measurements. To be fair, it takes me about an hour and a half manually to get to that same number of speakers. So it's a difference of an hour.
But do you think it's the same outcome?
No, not at all. I take an hour longer to produce something that I know is good, I can listen to, I can reliably go, it is correct. And that's the difference.
Now, do you think softwares like Dirac, not to just select out Dirac or generalize, all those auto configurers, do you think some of their systems, they kind of use the easy route on how to adjust the speaker?
No, it's the other way around. And
how is that?
If anybody from those companies is watching, they'll want to kick me. They're overcomplicating it. If you took a deep dive into the theories behind how they're treating the impulse response and what they're doing for correcting it, it's extremely heady. And it goes so far that it starts tripping on itself. It's kind of like if I ask you to juggle 3 balls while riding a unicycle backwards. You're going to fall unless you know how to do it. Actually, the XXX president of CEDIA knew how to do that. But it's not that complicated, and they're overthinking it. So the guys from Anthem have a thing called Anthem Room Correction, ARC. Very simple. The way they're going about it is that simple. It's look at the response. And theirs works most of the time really well because it's simple. And most of the other ones, if you look at the theories behind most of the other brands, I just don't want to name them, you look deep, it's really sophisticated, really complicated, takes a shit ton of processing, and it actually sometimes just trips on itself because it's trying to do too many different things. And I'm not going to say much more than that. This could literally become a shouting match if everybody was in the room about it.
Oh yeah.
And in the end you go, okay, well, if you're so good at it, let's go through 3 different rooms, let's hit the button and tell me that in the end, compare the pink noise test, it always comes back right. And then when you're listening to Snoop Dogg, it actually sounds right. Look, it doesn't sound right, doesn't sound right. Like everybody confirms.
But this is all subjective at the end of the day.
In the end, it is subjective.
So
But
we could all,
it's
even whatever
control.
any one of us feel, the person who is purchasing, their opinion is probably the only opinion that truly matters.
Well, it's like
correct.
when we used to calibrate the 3-gun projectors.
Yeah.
And we'd pay a guy $600 an hour to come in and set what he thought was the perfect picture. The customer go, oh, it's so dark, I don't like it. You know, the customer does have the last word.
They do. The thing I do find, out of 100 calibrations I do in this manual way with the auricular, the binaural auricular confirmation. You like that?
Yeah.
I do binaural.
I like that.
Wait, what's that again?
I find that in the end, when I bring the client in and I give them a demo, they're like, and I've had one case where the guy's like, that's just too many highs. I'm not used to that. And you go back to what he's been used to listening to, is stuff that sounds like this. That's what he's used to. That's what he wanted to hear. Fine, we'll just tone down the top end, done. But everybody else, out of those hundreds of of installs I've done, in the end the client's like, wow, that is, oh my goodness.
But even like how you calibrate is like we had another calibration person calibrate a room, and in some of the concepts you're talking on, you're spot on. But even how they calibrated, the way they spoke about it was a tad different. It's funny because I even brought up to them and you know, of course everybody has a lot of respect, but you know, at the same time honest that he's like, we're in a different mindset. We do it different, but not to take no one took anything away. You're definitely, you know, someone. But and maybe you can elaborate a little bit on that, on what your mindset, what makes you different.
So it's interesting because the way I'm calibrating is no different really than any of the professional audio calibrators do it. That's where I learned. There's one thing I do differently, which is that confirmation with the earphones, because I've learned over time that you just draw a target curve and it doesn't always sound the same because different speakers have different sound power and different rooms have different reflection decay time. Those 2 elements of chaos mean that what you're measuring is only a rough approximation of what it sounds like. So that's one thing that's a little different. And I've tried to train people that work for me to do that, and at the beginning there's a lot of resistance on that. So that's one thing that's different. The other thing that I think I do differently, is going to sound weird, is I don't start calibrating until I open a 40-page checklist for all the things I'm going to do. Most people just want to get at it, and it's like, I want to let it, and it's like, first things first. What's the name of the client? What's the street address? What's the equipment? What's the inputs? What's the outputs? What's the voltages? Check the frequency response at the speaker terminals. Check the distortion. So I go through all of these other things before I even start equalizing that confirm that the system is working. And I don't know anybody who goes through that level of asinineness. Why? Because every time I do that, there's a problem. I detect a problem. So what's the point of going to calibrate the frequency response of a system when a speaker's out of phase, when a driver's out of phase, when a speaker has the woofer and tweeter connected backwards by the factory, and go, what's up with this? You throw Dirac at that, it's going to try to correct it, not knowing that it was incorrectly hooked up. When there's oscillation at the output of the amplifier because the combination of the amp and the wire and the speaker have a capacitive loading that's causing the amplifier to oscillate. I actually check for a lot. So I haven't even started to talk about what I do in a calibration session. But it takes me 10 hours because 5 of that is just verification. configuration and verification. And then the balance of it is 2 hours of equalization, and then an hour or two of listening and an hour of client demo. That's how I do it. But when you finally get down to the putting up a mic and measuring and equalizing, that's the same as anybody else would do it in the professional audio industry. It's the preparation. I use a combination of impulse response, a combination of impulse response and what's called FFT, real-time analysis, with pseudo-random pink noise. Some people are very much in one camp and some people are in the other camp. I use both. I use a combination of near-field response from the speaker and far field. So that's one thing I do a little differently, which is I measure, if this was it, I measure at about 6 feet from the speaker, between 4 and 6 feet from the speaker, to make sure that what it's feeding out before the room affects it is correct. And then I measure 4 microphone locations in the room, and I look at both of those and I average those together. That's called sliding band integration curve process.
Which is definitely different from your commonly configuration of it, where you're doing multi-point.
It's that's the thing I've realized is that you got to start off with a speaker in which the direct field, the stuff that's coming right out of the speaker, is smooth response before the room tackles it. So first thing I verify is that what's coming out of the speaker from 500 hertz on up is relatively flat. If you have a speaker that has a bad response and you measure it far away in the room may change it yet differently. You want to know what the direct response is. That's one thing I do. It's not really different, it's just an extra step. There are measuring devices that have changing windows in how they truncate the impulse response, as it's called. Whereas you go up in frequency, it gets to be a smaller and smaller time window, and it's measuring more and more of the direct sound of the speaker. That results in the same thing. It's just, you just don't see why the differences are there. I measure the near field and the far field. That's part of what takes 10 hours total. But with all of that data, in the end, when I'm done and I hit play, it usually sounds just like the dubbing stage or the mix room. And sometimes it needs a little tweaks here and there. It's like a little more surround, a little more bass. But when I'm done with that, it's a good replica of what I'm used to hearing. And then when I bring the client in and I go, let's do the demo, there it was blown away. You could argue that it'd be blown away with just about anything that goes boom boom and has some surrounds. True, but I've been in places where the room was already calibrated by somebody and it had a bunch of problems and speakers were in the wrong, like in one of the rooms I was doing earlier this week, the people were like, it's amazing. Yeah, except that the back speaker sound is coming out of the top left. It was still amazing. They didn't know any better.
The level of clients that we're working with now have been accustomed, and they're going to their friend's house and they're going to these custom theaters, and they're starting to know what's good and what's not.
Right. So David, you can't hear him on the mic, but he's saying that the level of clients we have now, actually I'm going to paraphrase it a little bit. A lot of our clients are now on their second or third theater and or have friends with theaters. So what our industry was able to get away with in the past, which is a big picture and loud sound, you can't anymore because they've already experienced what it could sound like before. So we got to be a little more careful. It's like they're not on their first car anymore. You know, they can tell the difference between that old beat-up Nova and, you know, a really nice M-Series Beamer.
Honestly, in the advent of social media and the internet, the smoke and mirrors doesn't work anymore. You know, the bullshit doesn't sell. You know, the guy down the street, he's going to be more than vocal to tell about why this isn't good.
Yeah.
And they're going to have friends. I think we're seeing more of that where now our systems actually really have to be amazing. And also, there is this much bigger negative push where people love to tell people like bad things. Like it's amazing.
Yeah, there's a lot more negative information than there is positive. Anyway, so you guys, I mean, this is not a course on calibration, but you guys see what the tools are, right? So again, the tools are a mic, a USB cable, a mic stand, a laptop, either Mac or PC, which is what goes here. This is the measurement and signal generator device. This over here is the controller or the amplifier that's driving that speaker. And what you're trying to do ultimately is to result with a target curve. You see how this has a a bit more bass, it slows down. This is 100 hertz, that's 20 hertz. Generally more bass and it slows down. If I had more time, I would smooth that out a little more. I just did this in 5 minutes earlier and got to a point, it's like, yeah, sounds pretty good. You also don't want to over-obsess about this. You want to get to a point where it's relatively smooth, and you can keep trying to make everything flat, and at some point you don't really hear the difference. It's just like everything else. They're smooth enough, and then beyond that, you're just academically wasting your time.
Now, something someone told me once when I was calibrating is that at one point, if I feel like I've been calibrating for too long, I need to stop and go listen to something else, and then come back and listen to it again.
It's kind of like when you're reading the same page and trying to understand it, you need to stop. Oh, hello. It's like when you're reading a book and you're trying to read the same paragraph over and over, and you're lost in it and you're used to it. So you do something else, and then you go back and you have fresh eyes or fresh ears.
It is true that it's funny. Calibrating is very much the same process as mixing an album. What you're mixing at the end of the day is going to sound wrong the next day because you're tired. You're tired of listening. You're just tired, and you start to do stuff that you go, "Wow, Dave, you've been there, right?" You come back the next morning, it's like.
Then how do you do it for 10 hours?
A few secrets. Lots of really good cappuccino. Actually, so there's a few things. One is I'm wearing earplugs most of the time.
Interesting.
So, and I have these special earplugs that don't block out all the sound. They just turn it down 12 dB. So the eargasms, yeah. I lost my Etymotics, they're gone. But the eargasms are great. You put them in, they're really comfortable. And you still hear everything, it's just turned down. When it comes time to actually listen, they come out. But the entire 10 hours, actually, remember that in the entire 10 hours, 5 are spent like crawling around the back of the rack with the headlight on. That gives me more of a headache than anything is that headlight, right? And I got to have my glasses on because I'm old and I can't see. And like, okay, what's wrong with this connection? And looking at this XLR cable above the ground. So 5 of those hours are spent not listening or measuring, just fixing stuff. It's normal. It's not an indictment on the techs. You make me wire up a rack, and it would take 20 hours to unravel it. It's complicated. There's just a lot of stuff to hook up. So 5 of those hours are config and set up, and that's all computer and running around tools, soldering irons. And then there's 2 or 3 hours of tuning and EQ, doing what I just did quickly here, pink noise, pseudo-random pink noise. And then the rest of it is listening. So up until that point, I've got earplugs on, and it's okay. Caffeine helps. And then by the good graces of what my mom and dad gave me, I just have a shit ton of energy. And I can actually do this. Most people after the 10th hour, they're like, God, I can't believe you're still doing this. I'm like, yep, and I just keep on going.
We are beyond the 4 hour.
We are indeed. And I'm almost done. I have one slide I want to show you, and then I'm going to actually shut up.
Just give you a warning because I know you have another calibration.
I have yet another 2 calibrations to do today. Okay, so this is the kind of the final part of the topic of the fact that we do digital EQ and measurement, and it's all on the network. It's all IP controlled. I mentioned this earlier, which is that right now what we've got is a little rack with 2 amplifiers on it. There's a little switch in the back, a little network switch, and it's going to this cable. But this could be a micro version of a rack, all on a network. I can go to the house, open my laptop, turn on the application, see all of the amps, and go tune them. But then I can also go back to my office, and as long as I have a login to that system, which you know how to do that, right? I can do the same thing from my office. I wouldn't want to calibrate somebody's system from my office unless you were there with a microphone. And I have done this about 30 times now, because I can't be everywhere in the world, and Manny, the 2 of us do the calibrations, we can't be everywhere. But we actually either have somebody get, or we'll send them a microphone like this, and by remote, I can sit in my in-laws' office, or their home office in Argentina, and calibrate a system in Belgium. And as long as you know what you're doing and you're plugging things and you're listening, I can assist you through the process, which is really cool. So we can do remote calibration, but we can also do remote diagnostic and error detection. So once again, the application that's in here can be programmed to do a diagnostic every minute, every 5 minutes, every 15 minutes. I would recommend doing 15 to 30 minutes. You don't have to do it more often than that. and send back an error report if something's not right. And then I can dial in and go, what's up? What's going on? I can start to poke at it. I don't have time to go there right now, but there's a whole bunch of different things I can look at to figure out if there is a problem. So a really cool thing we can do with a client's authorization, we can plant a hidden microphone like this somewhere in the ceiling somewhere that's measuring off axis, therefore not the right response, but a benchmarked response of the room. So when I get done calibrating the room and it's all the right thing and it sounds great, if we can get you got to be careful. The federal laws require you, if you're going to put a microphone somewhere to get authorization for that, you can hit a microphone, you measure the response of all the speakers at that microphone. They're all going to look weird because the mic's not in the middle of the room, but that's your benchmark reference. And when the client says, I don't know, can you check it out? It's like you go, okay, stay out of the room, you can generate tones and you can see at a microphone electroacoustically by remote what's going on. You can't listen to it because all you're seeing is these bands on the thing. You can on the screen. You can also give the client control of it, which is you can give them a switch for the mic so that if they're paranoid, you go, look, I can only do this when you flip the big red switch to on the microphone. But that's really cool because you can actually get an electroacoustic data point by remote. So that's all available. And I think that's really key at the level of clients we're dealing with, to give a white glove, really very well catered service to say, we're going to get you a system. It's amazing. It's kick-ass. It sounds great. And it'll be up 24/7. We'll verify that it's always working. No worries. It's very reliable. And if for some reason something doesn't work, we'll know it before you do, and we'll be able to repair it before you even notice something's wrong. You had a question?
Yeah, now with everybody having third-party monitoring system, may it be Oversee, Domos, Avic, how does a system like that integrate into that? Because at least my guys and most of the other companies I know, their guys are going in, or gals are going into the software to kind of monitor everything.
Yeah.
So does your device do SNMP, anything like that?
So we don't, Domos is probably the closest we have of a relationship for a deal. They're all French, so I like to talk to them. But right now, we're keeping it simple. We're not trying to integrate it into a big other package. All you do is you just need to tunnel into the system, and you're like what I just did here. Nothing more complicated. And if you can plant a microphone over there, if you plant a microphone over there, you also need a NUC. You need a little computing device that's over there, a little thing like this with a USB input. It's all you need, and you can do it all. Depending on the surround decoder they have, if they have one of the ones that has a built-in generator, like the Storm, the Trinov, and some of the other ones that have a wideband generator, you don't need to connect the NUC to it because you can just say, give me pink noise in the right speaker. And just by remote, you just dial and go, you measure it, you're done. Some of the other surround decoders, you actually have to have a signal output out of the NUC into the surround decoder so you can generate signal to be able to test it. So that's where I'm sort of a fan of some of the higher end decoders that have these testing capabilities. Not because, they're more fluid sonically, all this other, they're good sounding products, but just they're easier to control by remote.
What's your favorite cheap preamp?
The answers are interesting, and I'm probably going to just leave this here and they're going to say goodbye. At some level, above a certain level, they all sound good enough. Good enough being, that the sound, it just doesn't sound distorted. Then I'm into how easy is it to control? How reliable is it? Does HDMI work all the time? And I've generally found that most of the manufacturers have all obsessed over this. And one year the Yamahas will all work great, and then there'll be a change in HDMI, and then it's the Onkyo's that all work great, and then HDMI will change, and then it's the Denons. Meh. I've had them all. They all work really, really well. I will say, I'm going to give you a piece of data that most people aren't going to think. I like the fact that Yamaha gives me, even at a relatively low cost, equalizers for each signal inside a cheap receiver. So you go into the Yamaha receivers. They cost the same as whatever, right? They sound good enough. And on each one of the channels, you have to kind of dig deep. You have to know how to program them. There is either a graphic or a parametric EQ for each output on a receiver that costs $500 or $600. And I like that to do everything we're talking about over here. I also like the fact that you can program the surround processing mode for each type of input for each type of signal. I like that. So I like to say, okay, stuff that's coming in from my Apple TV, when you see a 2-channel signal, leave it in 2-channel. When you see a multi-channel signal, do that. And I like to be able to program that so that other people in the household that turn buttons that get it all screwed up, it doesn't really matter. I go back to the input and boom, it's back to what I wanted to do. And that's not so much about sound quality, it's just about features in the product, right? They've thought about it from a user point of view. And other manufacturers do that too. So I will conclude by saying that I mentioned this right in the beginning, that part of what we're trying to do to help you guys is to offer packages, not just a speaker. But if you know you've got a client in a 600 square foot room and you got to put out a quote quickly, we have a system for a 600 square foot room that's called Cinema 2, where if you want kick-ass sound and you can get $160,000, $161,000 retail in the budget, you can get 3 Rixos Ls, Rixos Ms, the top speakers, which are the Omegas I didn't have time to talk about, these 4 subwoofers, and a design service where we actually figure out the room, calculate it all, produce a 25-page plan set for what you're going to build, and a bunch of acoustical treatments, which is a collection of some diffusers like this, some diffusers like this, and some, I thought you were going to come and help me carry that. Are you going to stay? Are you going to stay? Are you going to stay? Perfect, perfect, perfect. A bunch of absorber panels. So this is a dense fiberglass and rock wool combination that provides absorption. There's a bunch of different products. Can you hold this up here? There you go. We also have some corner traps that are made to go in the corner. They're a wedge shape. They've got a resonating front with a damped low frequency absorber. So that's all included in there. And each room size has a different combination of how many of each you get. And included in that is a calibration. So imagine you got a client that says, okay, I'm building this room. What's your bid? And you're like, yeah, I got to know by tomorrow. Like, okay, I got a lot of work to do. What do I do now? You know how long it takes to put a quote together. I've done it. All you need to know from the client is the length and width of the room, not even the height. We'll just assume that given a certain length and width, the height's going to be a certain value. Find out the length and width, and if they don't quite remember, just kind of try to get an approximate, and then you go to our table and you go, okay, well, that's a Cinema 2. And all of the audio is $160,000 retail. You need to add a surround decoder, so whichever one you want to do. There's your audio. On the video, you pick the video projector do you think is going to be right for that size room, and I can help you figure out how many lumens you need. It's a really easy calculation, and you pick the version that's got 2,000 or 3,000 or 5,000 lumens with a screen about that size. Now you got your video. See, so we can help you get through that thing I hate, which is a coding process. It can take a full day to just figure out what the answer is. I can help you in like 10 minutes figure out what is the audio and video. Control system, labor, that's up to you. Can't help you with that.
And an AcoustiSmart can put all the walls together.
Right.
Come in and they make it all beautiful.
They can make it all beautiful. Then you'll need a quote from those guys.
And you need a sound transference
They help you there.
So that's one approach we have, is these packages. These are all the retail numbers, and there's different programs at different levels of dealership with discounts that start at 40 points and go up to 55 points, depending on your business volume. But we've got 5 different ensembles, packages, that vary in basically horsepower. As you go up, you get more speakers, and they're bigger. It's just a bigger room, okay? So there's a range of retail prices, and there you go. All right? So that's about what I wanted to say. I can get you the PDF of this presentation if you want to distribute it to people.
The video will be on YouTube.
I know I part of why I came here was also for the calibration, and not that the room acoustics and everything. I'm sure we didn't get to it first because I talked too much. I'm fine with that. But can we continue that conversation to get into those?
Into the calibration practices?
Maybe we'll do a fireside chat.
And the placement.
Mike.
So
as a live Q&A.
Yeah, then let's do it.
So
Maybe it could be live
so
Q&A.
a few things on that front. So I do teach calibration at forums like CEDIA. There's a few different YouTube channel things that I've done with groups that do education about calibration. I have a series coming up in the future, but I think a fireside chat where we talk about all of the things relating to calibration would be really fun. That would be to get through it. To really teach it, you got to be ready. It's a full day to like get through all of the concepts of like, because it is not just putting up a mic and measuring the response and equalizing it.
I'll be honest with you, I love telling people the brutal truth of how I do everything.
Yeah.
Because then they don't want to do anything. So let's show them all exactly how to do it, because nobody wants to do any of this.
Yeah.
The people who want it are definitely not going to do this.
Yeah.
They want to hear it and enjoy it.
Yeah.
You know? And those of us who are faking it, it's going to be really apparent to the who when it's like, hey, where's all that other stuff you're supposed to do?
Yeah.
So that's why I love shows like this and showing it. And I love that time, because even in the amount of time, they can be like, hey, I don't want to watch the whole video, but wow, that's a 3-hour video. So that alone tells me should take like 3 hours then, you know, it's a 3-hour video.
Yeah, I mean, I've taken 16 hours sometimes to do the full commissioning and calibration on a system because there were a lot of problems. Problems being normal, like this thing didn't configure, needed to do a firmware update. Wow, the IP of this isn't talking to that thing. Ooh, this wire is not working. This thing is buzzing.
Or you had to solder somebody's connections. Remember that? You know what I mean?
I did a theater for, I never know whether let's just say one of Hollywood's top actors years ago with an integrator in LA. Very well-known guy. And we couldn't get the bass to work. It just was sounding horrible. And we're troubleshooting and troubleshooting and troubleshooting. It turned out that in the wire coming out of the surround decoder and into the distribution amp for the subwoofers, the actual line level cable, there wasn't a short, but the ground, one little wire off the ground shield was really close to the center pin. And at a high enough voltage, it ionized through. It's called a Schottky diode, is that effect. And so bass is all fine until you turn up enough, and then one half wave is shorting out. I'll throw you for a loop, because it's like it's invisible. You know, you can barely see it.
Try to find that one.
Try to find that one. And so I had my big old oscilloscope that I always traveled with at the time. Now I have a little bitty one that's all in there, and I'm measuring it. I can see it's clipped half wave at a certain voltage. It's like, okay, there's a wire on almost short mode somewhere in here, and start chasing that down. That stuff will eat an hour or two, but what are you going to do? You got to get it to work. And that's, to me, that's part of calibration. I know it sounds like troubleshooting, but it's part of like, okay, everything's hooked up, let's make it work.
That's the Grimani magic, though. You fly where you need to go. You go, like, you go put on your Superman outfit and you go make it happen.
You got to make it happen, yeah.
Again, I think those of us that are playing in that realm respect what it is, because we all sit in the fire all day.
Yeah.
So when a brand respects where it is that, like, what our job is, and you're under the same fire,
yeah,
I think we all play much better together.
Yeah, that's the way to do it. And I'm totally happy to teach this. I have been teaching this at CEDIA, all of those steps, all those things I do. And if people are willing to learn it, then they go off and then do it right. So cool. All right, we're completely out of time. We're past negative time. Thank you guys so much. Thank you guys for watching. Enjoy the rest of your day. Ciao, ciao. David, thank you.
Picture all of us together before we all leave.
Go right there.